Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Ladies and gentlemen, welcome back to another video or to another live stream. Okay, let me actually share the live stream. Marty Flowers, hello, welcome to the live stream, welcome back. How is it going? Just going to wait for a bit until people join in. I'm good at a nightmare that woke me up. It's otherwise a very nice day here. Oh yeah, let's go. Sunny and clear sky, but not hot. Perfect for another Zig stream. It's very hot right here. Well, at least in the day. The nights, I don't know. Currently it's a little hot, but anyway. But overall, these days on Morocco, or in Morocco, it's kind of very sunny, so. Okay, just going to wait just a bit more for interested people to join in and we're going to start. Yeah, it's around 3 minutes and 40 seconds already. Cool. Gotta need the train to navigate this code. Did I just write all of that? Bruh. Alright, it's already 5 minutes in, so I think we're going to start. Okay, well. That's gonna be interesting. So, previous live stream, so far we have got you know, the setup basically. We got a window, we got an instance, we got a adapter, and we also got a surface, and also an event loop, etc., etc. So far we have got, and of course the function pointer loading stuff of the Vulkan library. So far we just got a window full of trash, and that's pretty much all we got at this point. Okay, cool. So let's start by just some things that maybe just minor things really. Just a bit of improvements there. So first of all, I've actually asked on the Zig server like on how you can detect Android, and I got a great response. Let me try to find it though. Android. There you go. Okay. So I asked why a CD built OS tag doesn't have Android, and this guy have said because it is Linux. Yeah, just as I expected. I think you specify Android as the ABI. And in fact, if we check out on the documentation, alright, hold on a second. Okay, cool. Let me just go on and alright, where is the browser? Hold on. Where is it? There you go. Okay, cool. So if we go to std docs documentation and we look up for target, there you go, built-in std target, right? You can see that there is a CPU, OS, ABI, OFMT. If we look into the ABI though, we can find that there is Android right here, which is interesting. So that's how you check for Android. You just check if the ABI is Android, and also maybe is the OS is Linux. But I think checking the ABI if it's Android is probably enough, I guess. But yeah. So how to do that? Well, instead of doing this stuff right now, I think what we could do, we could we don't need this anymore. We could just import what is it called? Yeah, built-in. We could just import built-in. Okay, import built-in. And now what else? What's the problem? Did I miss something? Okay, there. So if not built-in, oops, dot target dot ABI is equal to Android, then, well, if built-in target ABI not equal to Android, then we could basically create the surface. And yeah, seems to work. So there you go. Now we don't need to ask SDL for the platform. We just can use Zig directly, pretty much. Nice. The other thing that I'd like to do to improve this is that I just want, although it should actually like it should be fine, but just in case of that it did enter foreground before even creating the surface, I would check if maybe surface. Okay, so if maybe surface equal null, then actually override it. Otherwise you would have a memory leak because we wouldn't release the old surface. We would just override it on the option, which is not a great idea. So just to make sure that that's fine. In SDL3, the behavior of these events can change on desktops, right? But currently on desktops, these guys don't run anyway, so we're good to go. We're fine. This will only run on something like iPhone, like Apple, well, phones basically, and Android, etc., etc. So yeah, that's pretty much it for that one. Now what's next? Let's see. SDL log error. The other thing that we may want to do is to kind of create a function that could take whatever vacay result and it would map it to an actual zig error, too simply. Now we already know the actual functions that we have currently, and we could look up the wiki for those functions and basically add the mapping of those errors there. So for example, what we could do maybe is fn map or map vacay error, I guess, or let's see, translate vacay error. I guess let's just go with map vacay error. Not good at naming stuff. Let me know if you have a better name. It's gonna be basically either void or an error, too simply. And we're going to return a switch. And in fact here we're going to get a vacay result. How to do that? c.vacay result. There you go. Now we're going to switch on that result, and of course the result is just an integer, I think. And basically, if it's 0, then we know that it's a success. So that's not an error. We're fine at that point. In fact, you know what? Let's see. 0, 0, 0, 0. Now I think I'm going to basically say if result is greater than or equal to 0, which means a success code, then we're basically going just to return. We're not going to do anything, like just void basically. Nothing there, because it's a success. But otherwise, if it's not a success, if it's a failure, which means it's less than 0, then, well, I'm going to check for every function what it actually can throw, or whatever you want to call it. So let's go to actual Vulkan registry. The first thing that we had, the first function that we have used, I believe, is let's see. I'm just going to check for all stuff that have a less than 0 there. Enumerates physical devices, create instance. Yeah, so far. Oh, what the? Why there's, oh yeah, I see, makes sense. Okay, so let's check, for example, for create a device. Vacay, we're gonna find the registry, there you go, and you're gonna tell it, it's gonna tell you the possible errors, too simply. But the thing is, we have to look up those errors, etc., which gotta be quite painful and quite time consuming. Well. Currently, though, I think I'm just going to say else unknown. But later on, we could fill that up basically. So else error dot unknown or unimplemented, depends. But I'm just gonna say unknown for now. And yeah, but it is indeed an error, so we know that it is an error. Cool. So that's pretty much it. Now, instead of doing that weird thing, so for example, this guy, instead of doing this, we could say, too simply, I guess, map try map vacay error, and there you go. So it would receive basically the results from this function. If it's greater than or equal to 0, which means a success, then, just gonna go ahead without any problem. Otherwise, it would actually return with an error, too simply. So yeah, that's pretty much it. unknown vacay result, I guess. But anyway, I'm going to do the exact same thing with the other stuff. Map vacay result. It makes things much easier to deal with, I guess. Map vacay error. Remove this craziness. And then later on, when I'd like to, I could too simply go ahead and map the errors correctly. So what's going on in here? We don't need this, but we need this. There you go. Okay. The other thing is map vacay. Oh, make sure to add a try there, and then same thing here. And we don't need much cleaner. I don't know why I didn't thought about this earlier, but there you go. Map vacay error. Okay, what else? Let's see. I think we've done all of it, maybe? Isn't it? No, there's still this guy. So let's actually just do this and then do a map vacay error and then add that guy there. Of course, try it out. And this should work just as before, but much cleaner and also much more maintainable. Because right now, later on, to get better errors, I could just add error mappings here, and we should be good to go, too simply. So yeah, pretty much. So that's it for that one. Next up that I'd like to do is to possibly separate this extension dispatch into its own kind of struct, I think. In fact, maybe I'd like to be able to just pass in like some struct into a Lloyd function and it would do the job, I think. So let's see. I mean, if I say fn Lloyd here real quick, and then here you would get, I guess, any type, I think. Like for example, let's see, dispatch, and it would be any type, I guess. And well, dispatch like this, it's gotta be a type. Okay, and then basically it would just simply return that this dispatch, I guess. So what we gotta do now is to simply have something similar to this guy, I guess. And now, instead of this, I'm going to say dispatch, too simply. And yeah, I'm sure that it always will start with vacay. But what I'd like to add though is, you know, like for example on KHR extensions, on core extensions, you're gonna have a KHR here. So I'd like to add that too, comma. Okay, let's see, const, I forgot, well, just like that, I guess, const u8, there you go, u98, u9, u8, let's go. And I guess that's how you do it, pretty much. And of course, this is the suffix, I guess. And what's going on here? Well, call it dispatch type anyways, dispatch type. Okay, try Vulkan library. We do need the Vulkan library, interesting. So let's get that too out of the way. And by the way, this should be comp time, I think, no? I think so. And then comp time here for suffix, I believe. And then finally, there's gonna be the Vulkan library to actually load that from. And I mean, coming to think about it, since we only need the Vulkan library, why bother doing it here though? Let's see. Where are we getting the instance, by the way? Interesting. Yeah, where are we getting the instance? Oh, yeah, there you go. Oh, yeah, makes sense. All right, so in fact, let's see, Vulkan library. Well, I guess probably we could put this in the Vulkan library instead of the instance, really. What do you think? I think so. Maybe. So c.vk instance. Well, instance, it's c.vk instance, I guess. And of course, the Vulkan library. I didn't add that yet. Interesting. So for the Vulkan library, I'm going to actually put it inside of, I think maybe inside of the Vulkan library. That may be a better place to put it, unless if I'm missing something here. Dispatch type, there you go. Now the Vulkan library would be basically self. Now self would be the Vulkan library. Let's go. Isn't it? Self, now, in fact, we gotta change this up. Let's call it dispatch, I think. Return dispatch with itself once again. It's here, dispatch once again. And since we removed that from that place, I guess we could just say dispatch. There you go, cool. And by the way, we don't really need to put them in their own kind of variables. We could just inline those, honestly. Let's actually also put that there. And we don't need those variables. The other thing is that instead of khr, this would be suffix, too simply. And there you go. So now let's try to use this Lloyd function with the core dispatch of the instance, I guess. So where is it? Where is it? I believe right now we don't need this weird stuff, I guess, anymore. And then we could just simply say, so it's dispatch. That's kind of like the core dispatch of the instance. So where we're actually doing that, guy, where is it? There you go, we're doing it here. So instead of try dispatch.init, we're going to actually say Vulkan library.lloyd. And then here we would give it the type, which is basically dispatch. And the suffix is none, because it's a core, it's core functions. They don't have any suffix. And then here we got the handle. Now, maybe I forgot one little thing, which is the errors. Yeah, I forgot to actually add the errors there. And yeah, I think that's pretty much it, I believe. Let's see if I forgot something. But I guess this should be good to go, really. And oh, it worked from the first try. How? No idea. And let me make sure this works on release mode though. Never falling for that again, hopefully. Release fast. So you also have to ask yourself why the code works, not just why the code didn't work. So yeah, try map vk error. Alright, much cleaner. Now, why I've done this, because now, instead of doing it this way, I'm going to remove these guys and put them into their own dispatch. So const surface dispatch equal to struct. And then I could too simply put these guys there. but I don't really need to suffix them with khr because it's gonna be done for me too simply, at least in that place. So yeah, that's pretty much it for that one. Now what I'm not sure about yet is, do I want to make this as part of the instance or as part of, I don't know. So yeah, probably a part of the instance, honestly. So let's go ahead and do that. So fn Lloyd service dispatch, or maybe I could just say too simply, let's see, surface, maybe surface. There's a lot of ways that we could go about this, but let's try something. Okay, what if we have done, you know, like const surface, maybe surface extension or something like that, or surface dispatch or whatever, is equal to Vulkan library dot Lloyd. Then here the dispatch type, which is basically instance dot surface dispatch, and then you'd say suffix is khr, and then the instance is instance dot handle. There you go. Of course, try this out. And with that out of the way, okay, instance dot handle. So now we got the surface dispatch. Now pretty much could use that to destroy the surface and get physical device surface stuff, I think. Okay, let's try this out real quick. No field or member function named get in main instance dispatch. Yep, exactly. So surface get presentation support. Now it wouldn't need just the instance, but also the surface dispatch, isn't it? Or maybe we could say like surface kind of extension struct, possibly. Like maybe we could say like const surface khr equal to a struct, I guess. Or just call it surface extension because you don't know, the suffix may change. So let's call it surface extension, I think. And then you too simply say, I guess, fn init maybe. And you would too simply, oh, sorry. It's either an error or surface extension. Well, instead of surface extension, we could just say this or self. But of course we have to add self here. Pretty cool stuff. We don't need a dinit function though. And what it's gonna hold, basically, it's gonna hold. And honestly, since that's the case, now we don't really need to put that dispatch struct inside of instance. Like really. We could just put it in the extension itself. The extension struct. So where is it? There you go. Okay. Const surface dispatch. There you go. Now you'd basically say dispatch is, well, too simply. Honestly, now we could just say dispatch like that. And dispatch is of type dispatch. And of course, finally, there's gonna be an instance. I believe instance, just like that, pretty much. Now, what it's gonna do is going to return. Let's see, where is that guy? There you go. Let's remove that guy. I'm not sure how this will turn out, but we'll see. So dot dispatch is equal to this guy. but it seems like we need the Vulkan library. Okay, cool. In fact, we could probably access the Vulkan library from the instance, right? Yeah, I guess. Isn't it? Isn't it stored? Hold on. Yeah, it is indeed stored there. So let's go to the surface extension. All right. Now we're basically going to say instance.vulkanlibrary.lloyd. So we just need the instance. Now lloyd instance.surface_dispatch khr instance.handle. Cool. Cool. And also we need, and other than the dispatch, we need to store the instance to equal to instance to simply. And I'd like to change the order of these guys, I guess. And there you go. Right? I think so. Now, what we could basically say, after creating the instance, we could basically load in the surface extension. So surface extension is equal to surface extension dot init instance. Too simply. And yeah. Honestly, I think I'm going to call these this something else, because whenever I see an init, I think that there is maybe a dinit function, which is not the case here. So I guess I would go with make. Maybe I'm going to start calling such functions make, which doesn't have a dinit. I guess so. Dot make. Or honestly, in this context, in the context of surface extension, we could call it Lloyd. Right, makes sense. All right, cool. So surface extension Lloyd from that instance. Amazing. Now to actually create the instance, etc., you need, so in fact, where is the create surface function? It's inside the instance, I guess, isn't it? So no, we gotta change that, I believe. Anything that relates to that guy, where is it? Request adapter. So there's just create surface, I believe. And now let's go to the surface extension. And we're gonna put that function here, really. And honestly, instead of having an init function in surface, I'm just gonna do this logic inside of that guy, basically. I think. So create surface. So instead of this, we're just gonna say this, I guess. What the? Hold on a second. Oh, never mind. It's SDL function. Okay. Alright, gotcha. Now we got the self, right? And we also got the window. Now I could too simply say self.instance.handle. But honestly, it shouldn't. No, it actually should be unique to the instance, right? Yeah, it should be unique to the instance. Makes sense. All right. So instance equal to instance. Well, no. Why do that? Oh, I see. Return. So that's gonna be, honestly, I think it's gonna be the surface extension, really, which is self. So we're gonna change surface to, instead of taking an instance, it would take a surface extension, too simply. And now it would take the extension, I guess. And now we could too simply say self.extension.dispatch. Self.extension.dispatch destroy surface. And since we have added that suffix, we don't need it anymore in such cases, I believe. Yeah, let's see. Has no member named surface dispatch. well, in fact, right now it's called dispatch in this scope. There you go. Consider using try. Yep. Let's see. Try. No field or member named create surface in main instance. Makes sense. So now instead of instance, we gotta use the surface extension. I guess. Surface extension create surface. Surface extension create surface. And then no field named instance in struct main.surface. Extension equals self. No field named instance in struct main.surface. Well, it should be self.extension dot instance dot handle. And there you go. Seems to be working fine now. Now, why I'm doing this, why I'm wasting time on this, because you could want in the future to have like optional extensions, and if they're optional and you cannot load them, then you shouldn't actually try to load their function pointers, because if you do, then you have a problem. So right now I just made sure to actually go ahead and like separate the extension dispatch stuff from the actual core dispatch. This is the core dispatch, and there's every extension would have its own struct basically. So I guess that would save us from a lot of hassle later on. So yeah, that's pretty much it. So right now we have surface extension, then we use that to create the surface. Now what's next? Let's see. So we got the adapter, the surface, amazing. Next up, I think, is the device. Yes, the device. Well, let's go ahead and do it. Const device is equal to a struct. Let's go, and then what we need. Of course an fn init function, but before that let's say const self is equal to this, and then fn init self, or an error of course as always, and fn dinit self, and then void to simply. There you go, cool. Now fn init. So now let's find out what we could do about this. Or in fact, instead of putting it here, instead of having an init function, I think we could just make a factory function inside of the surface, I guess, isn't it? No, not the surface, the adapter, sorry. The adapter, where's the adapter? Let's have a look into the adapter. That one could maybe create this, the service, the device. I mean, you have the instance, you have the physical device, and so I guess that's perfect for it. And I forgot about WGPU example. I'd like to inspire from their kind of program structure. So as you can see, request adapter, nice. Next up, you request a device. All right, amazing. I'm not sure why they called it request other than anything else, but anyway. So request device. So either an error or a device, too simply. All right, amazing. So how are we gonna do this? So you could pass in features and limits. I'm not gonna care about this stuff for now, but what we really need right now, we could just basically create the device right now at this point. Okay, let's try to do that. Well. I think first of all we need to actually load the function pointer for that on the core dispatch. So we gotta say create device. Create device std.meta.child c.pfn vk create device equal undefined. And there you go. Nice. Nice. Okay, so we gotta create device function there. Amazing. So now let's go back. Where is it? Okay, request device. So basically right now I could say instance. Oopsies, instance. Well, instance dot. Oh well, we need self. Yep, we need self. So self dot dot instance dot dispatch dot create device. Let's go. Now of course this could probably return a vacay result, so I'm going to wrap it in what is it called? Yeah, in map vacay error, right? Put that there and try it out. Okay, cool. Alrighty. Now we probably need what is it? Create device. Let's see what we need there. We need the physical device, device create info, allocation callbacks, and vacay device. Okay. Let's go back. So first of all, we have the physical device. And next up, we need the create info. Of course, the address to it. And create info is too simply std.mim0 init, I guess. c.vacay in device create info. And then here you basically give it an anonymous struct telling it the actual stuff that you need. So let me just copy this over for a second. And let's just put this in the comments. So first of all, as always, we need the S type. That's important. And then c.vacay structure type, and here I'm just gonna say device create info. There you go. Nice. That's the S type. Next up that I need is q create info count. Currently, I'm just gonna hard code it into one queue, just like WGPU. Later on, we may think about, you know, trying to use multiple queues, but for now, we're just gonna go with one queue. So okay, cool. Create info count is equal to 1, and then pq create infos. Or honestly, you know what? I'm going to just simply say, let's see, const q create infos, which is gonna be an array, I guess, of things. Of let's see, c.vacay q create info, device q create info. Let's go. So it's gonna be an array. Cool. And now what I can do with that is q create infos dot len. I think maybe this should be u32, right? Isn't it? Yes, it should. Interesting. So let's actually do that. As q create info len There you go. The comp time type is U32. Cool. Next up is qcreateinfos, which is basically address to the qcreateinfos array. What's going on in here? Okay, cool. All right, now enabled layer count, enable extension count. Extensions would also be interesting. So const extensions is equal to an array of, well, an array, I guess, of const, or of, yeah, const u8. But maybe it should be like, maybe it should be C here, something like that, I guess, maybe. And here I'm just going to say extension. Let's see. Let's look for a swap chain extension. Oops. There you go. VKK swap chain extension name. That's what I'm talking about. So it's basically, there you go. Where is it? Come on. What is the type? There you go. Const 16. It's like I've seen. Oh, well. Can I just do this maybe? I don't know. Well, let's just keep it right now like this until we have a problem. So there you go. Okay, extensions. So we need the swap chain khr. Okay. So here we need enabled extension count. By the way, device layers are deprecated, so don't use that. And then we basically say extensions.len, and then extensions p enabled extension names is equal to extensions. And there you go. Nice. pp enable extension names. Features, I don't care about that now. And yeah, that's all we got. Now let's create a qcreateinfo here. So let's see what it actually requires. Let's just copy this over here. And let's see. So s type as always is equal to c.vk qcreateinfo. There you go. That's the s type. pnext flags q family index. Okay. A q family index like this is equal to self.q family index. There you go. And then q count. Now we need a q priorities array. So const q priorities is equal to an array of floats, I believe. So f32, I guess, maybe. And then so q priorities, q count. So q count would be equal to q priorities.len, and then pq priorities is equal to the address of q priorities. Hopefully I got that right. And there you go. I think that's pretty much it. Now, other than create info, we also need, let's see, we need the allocator. So allocation callbacks, right? Oops. There you go. And now I could basically use it here. And then afterwards it would give me the actual handle to the device. Var device, it's c.vk device. It's undefined. And that's basically it. Now we just gotta return finally a device. Now a device though would contain the handle, which is basically c.vacate device, and it would contain allocation callbacks, so it could basically destroy itself. c.allocation callbacks. And what else? I guess it would also require the adapter, so you could basically access the other stuff that you have there. Okay, cool. So let's actually give it an adapter there. And I think that's pretty much it. Now, return handle is equal to handle, and then return allocation callbacks is equal to allocation callbacks, and then finally adapter equal to self. And there you go. Now I do expect some errors right now. Let's see. What are you kidding? Oh, because I didn't use the function yet. I was like, really? Impossible. Okay, adapter now. So, and we also need to get the queues though. Yeah. But let's just start with the device and let's see. Try instance dot request. Oops. Try adapter dot request device. Allocation callbacks null. Let's have a look. So expected type found type. What? Oh. Oh. Alright. Device queue create info. Let's go. What else? I think maybe I gotta actually cast this. So an int cast maybe there. I would probably need an int cast on other places too. Missing struct field be next. Oh well, I forgot. I forgot to zero in it. Interesting. Well, how to do that? Let's see. Zero in it. Let's try this out. And then read declaration. Well, I just want to try something here. So I guess we could basically say zero init. Now here vacate device queue create info. Then here the init, of course. Yep, exactly. So let's just grab these guys and get rid of this guy. And there you go. Zig build run result type int cast must have a known result type. Int cast. Yes, as u32 int cast. And I probably need that on other places too. So, oh, by the way, this should be like this, I guess. What? It worked already? Really? No way. Vacate create device, there you go. What the? Okay, let me make sure that this is actually right. Because I cannot believe I've done that without any errors. Well, almost any errors. So. Queue family index 0, nice. Queue count 1, nice. Queue priorities, there you go. Layer count 0, sure. Layer names, extension count 1. And the extension names is swap chain, nice. Enabled features, none. Amazing, we got it. That was interesting. So now we just gotta make sure to actually destroy the device. But before we can do that, we actually need a device dispatch now. So how are we gonna do that? Well, too simply, just like before, const dispatch equal to a struct. And then here we're going to say destroy device is basically std.meta.child let's see, c.pfn vacate destroy device. Let's go. Equal to undefined. That's destroy device. And what else? And also we need get queue though. I don't remember the name exactly, but I think that's it. I'm just going to copy this guy kind of, and then just say get queue, I believe. And let's say here pfn vacate get device queue maybe. There you go. So it should be get device queue. So yeah, pretty much. Destroy device, get device queue. Now we're good to go at this point. Now we actually gotta deal with the dispatch. Let's see. So after creating the device, we gotta load in the dispatch. But to do that, we need another function. We need another function, which is the device proc. So let's go to the instance dispatch. There you go. And here we actually need now, I believe, get device proc addr, I guess, if I can remember well. .child c.pfn vacate get device proc addr. Let's go. Call undefined. Let's go. And that's get device proc addr now. Interesting. Now we gotta have a init function, similar to the one that is inside of Vulkan library though. Where's Vulkan library? Okay, let's have a look into Vulkan library. So there is a load function there that we have created earlier. So just gonna copy this and we're gonna change it a bit for the device. And well, it's gotta be inside of the instance though. So let's go to the instance. Oh well, there you go. There's the instance now. And now let's just say fn, I guess, Lloyd. And then I'm not sure what to return. I think we'll see. Let's just actually paste this guy here, too simply. And now instead of Vulkan library, we could just say self here. Interesting. Comp time dispatch type. Well, here we're gonna say device dispatch kind of thing, I guess. Device dispatch type comp time suffix. And now instead of instance, we gotta go with the device. There you go. Now make sure to use that instead. Yeah, it seems I'll be all good at that point. Inline for device dispatch field dot name. Now get proc. Oh well. Now instead of get proc here, we gotta do something interesting. Let's see. So I guess self.dispatch dot get device proc addr. There you go. So what that actually returns, hold on a second. Let's see. So that returns, of course, a function, and you basically just give it a device. Just a device? And oh yeah, and you give it the name, right? Makes sense. So kind of similar to the other guy, basically. So where is it? There you go. Okay, so now instead of that get proc, basically, we're going to use get device proc instead. And get proc. Get proc. Well, yeah, I guess I'm going to honestly make it if and get device proc, honestly. That would make things much nicer to deal with. So get device proc, and it would be similar to get proc. So here I would just say get device proc, hopefully. And then, yes, you give the type, of course, as always. And then instead of the instance now, you gotta go with the device. And then vk, of course, that's the prefix. And then finally the suffix. Now let's actually deal with this guy. So we need all of this stuff, just like that guy. In fact, I'm just gonna copy and paste it and change the stuff that is relevant to us. Now, just instead of using get proc, what? Hold on. Oh, I see. So in fact, it's basically needs to be get device proc. Ooh. Ooh, interesting. Get proc. Oh, why? Yeah, why not actually put this Lloyd function there? Yeah, why not? Like, yeah, really. Yep, I see what's going on here. So that Lloyd function could stay there, but what? I'm kind of confused. Get device proc. Pointless discard of function parameter. Interesting. Yeah, I kind of lost it here for a second there. So hold on. Let's go back a bit. I kind of lost it. Let's see. Okay, stay here. So right now we have loaded the get device proc ADDR. Great. Now, basically we kind of need to do something like this. Lloyd. So this is actually using the Vulkan library, right? So yeah, we gotta need the Lloyd function here. So let's actually get the Lloyd function of the Vulkan library once again. And let's take it step by step. There's also a get proc. Okay, just get that Lloyd function, and we need to put it inside of instance. Instance, where is it? Bruh. So are we on instance now? Yes, we are. Okay. Let's put that there. Self in this case, well, let's just say this. Com time dispatch, well, man. Once again, I have to do that stupid stuff. Well, anyway. Instead of instance, we gotta go with device. Vacate device. And trying to go easy on this one. There you go. Device dispatch there. And yeah, now so we have here self git proc. Self git proc. Now here we gotta say get device proc. Self.get device proc. And now I think we gotta need a fn get device proc. Now in fact for that we don't want this guy. In fact we want git proc of the Vulkan library. Yeah, well, something like that, similar to that. So let's go now to the instance, back to the instance, which is get device proc. Device proc. Bruh. Request device. Alright, let's go. So now let's actually put this function here. Now instead of get proc, we already have a get proc func there. Let's say get device proc. And instead of get instance proc addr here, we gotta have self.dispatch.get device proc addr. And instead of instance, we have a device c.vacate device. And yeah, device name proc. Return PDR cast, and otherwise return an error. I think that's it. Great. Yeah, I think so. Makes sense. Okay, cool. Cool. Now let's go to the adapter. Alright, by the way, I don't need this anymore. Now, here where we're actually returning that stuff. Interesting. Well, the device. So here we're gonna have an instance of the dispatch, of course. There you go. Now we need to actually load that dispatch. Load. There you go. Device dispatch. Now this would be, I guess, device dot dispatch, I believe. And then here the suffix. The suffix would be, well, nothing. The device would be handle. And of course you gotta try this since it can error. And hopefully that would work already. Seems to be fine. But now let's find out. So self.dispatch.destroy device. And here we need the handle and the allocation callbacks. And I believe that's all we need to destroy device, I guess. Of course, self.handle though. And self.allocation callbacks. And let's find out. Now. Oh, I forgot to defer. Defer device.dinit. There you go. And now we have a device. Amazing. And there you go. Destroy device. Lovely. Let's go. Amazing. So as you can see, it actually works. Now, one other step for the completion of the device, the request of the device is to actually give the device and the queues too simply. So how WGPU does it is that, well, in fact, it gives you only one queue. So it basically gives you a tuple, a device and the queue. I'm not sure though if pairs or tuples are kind of possible on Zig. But honestly, I think I'm just going to put maybe the queue on the device, really, because why not? Unless if I see something wrong with that. But anyway, so I guess we could have like a queue now. Currently just one single queue, but later on, who knows. So yeah, pretty much now we got that queue. Now we gotta take that queue. So how are we gonna deal with that? Well, let's see, get device queue. Oh, we already have done it here. Okay, cool, great. So we could use it already. But one thing here. Oh, well, we got the dispatch here, which is nice. So in fact, let's just make it beforehand because we gotta need it here. So cost dispatch, dispatch, or I don't know what's that. Okay, so there you go, dispatch, and of course, finally, the queue is equal to dispatch dot get device queue. And here we gotta do, let's see. I do not remember what it takes, but if I would guess, it would take a handle and it would take a queue family index, I think. And it would take the index of the queue on the queue family basically. I'm gonna go with 0, basically the first queue. And of course, every device queue family is guaranteed to at least have one queue, so that's fine. I don't need to check for anything and don't need to worry about anything. So expected 4 arguments found 3. Expected 4 arguments found 3. Yeah, I missed something on that one. I don't remember. Let's see. Oh, yeah. So, yeah, I gotcha. Makes sense. So, basically the out variable, right? So, basically you gotta say var q equal to undefined, right? So, it's basically c.vkq, then equal to undefined, and now dispatch get device queue. I don't think it returns anything. It's probably just void. And then you just give it the address to the queue, like basically tell it where to put that queue, and telling it to put it in that variable. And finally, what we could do, we could just pass in the queue, and that should go great. Amazing. So I think right now we have done it. Get device queue. Yeah, I think it's void. Yeah, there you go. So it doesn't return anything. And that's, I believe, pretty much it for the device. I think so. Terminal. And yay! Let's go. So we're good to go. Now we got a device. The next thing and the last object in our crazy context creation Vulkan context is the swap chain. And I think when we created the swap chain, at least we're gonna have a black window. Not really, I don't really remember well if that would be the case, at least in Linux though, but we'll see. Either way, at this point we got a device and a queue. Amazing. Now, just one little thing, I'm gonna make sure that it runs on release mode. Release fast, or what was it? There you go. And it seems to be fine. Nice. Now, let's actually launch vk-config. And let's change to validation just to make sure we're on the right track. And we got a status message, interestingly. Let's see what we got here. So, okay, validation information. I think that's probably just an info though. So hold on a second. Don't tell me infos, just tell me errors and warnings. And let me try again. And yeah, there's no warnings and no errors. Amazing. Perfect. Perfecto. Perfecto. Nice. Nice, nice, nice. Next up, it would be the, as I said, the swap chain. Oh well, do you guys have any questions before we go further? Let me just revisit a bit the API dump though. And I just remembered I do want to change something about the extensions, which is to support macOS and basically Apple products. I need to add the portability extension. As you can see, good device queue. There you go. Nice. What? Hold on a second. Yeah. Makes sense. And of course, it's all vk success. Amazing. Lovely. So one other thing that I'd like to try is basically, let's see, is portability to support macOS and Apple products. So how I'm going to do that? Well, okay, let's go to the extension stuff. Enable extension count. So where we can actually do this, get device, enumerate, blah blah blah. Okay, get instance extensions. Alrighty. So there you go. So we're doing it here. Okay, so right now I'd like to basically, if the target OS is some Apple product, that I'd like to actually add the portability extension there to simply. Okay, how to do that? And do I want to do it here or inside of the instance? I think here though. Yeah. Okay, let's see. Let's find out. Get instance extensions. Let's go to this guy, I guess. Extensions count. cu int alloc. Now, depending on what we could do is const extra extensions, or what to do, additional extension count maybe. And I'd basically switch on built-in.target.os.tag, I believe. Right, now let me go back to the documentation for a second there. Tag, and let's find out the Apple products. Well, there's macOS first of all. Not sure about the others, I would guess. I mean, let me check one quickly. Where is it called? Let's see. Molten Vacay. So let's check Molten Vacay. This is basically a layer on top of Metal to add support for Vulkan on macOS and Apple products generally. And it supports up to Vulkan 1.2, and since I didn't actually give it an application info while creating the instance, I'm using basically the lowest possible Vulkan Vulkan version, so I can support as much devices as possible pretty much. So let's see what devices are possible here. There you go. Mac OS, iOS, tvOS, and Vision OS. Nice. So Mac OS, iOS, tvOS, and Vision OS. Okay, great. Let's find it out. Where I wanted to go. There you go. Okay. So Mac OS, iOS, and I don't think Vision OS is there. No. Okay. So Mac OS and iOS, and who? tvOS. I think tvOS is there. There you go. Okay, cool. So let's go back now. If it's Mac OS or I guess .os, .ios or .tvOS, then to simply make it a one additional extension for portability. Otherwise, 0. We could do it in a much better way, using in a much more flexible way and maybe reliable way, using array list, but I don't want to bother right now, I guess. So anyways, additional extension counts, there you go. And now here, I would just say plus extension count plus additional extension count. And now if it's one of these platforms, it would say 1, otherwise it would say 0. And now here I'm just saying extension count plus additional extension count. Nice, amazing. Now, what's gonna happen now is, okay, get instance extensions. Now after this, I would say extensions, index of extension count plus 1, I guess. No, actually no, because well, if it was 1, then I would need to take, yeah, okay. So extension count is equal to I guess KHR portability or something like that. portability enumeration extension name. There you go. So I'm just adding that extension portability thing. There you go. Amazing. That's one thing there. And what's other than that? What else? iOS. Okay, nice. Now, next up it would be get instance. Okay, nice. Now, where we're creating, now we need to add that to the flags too, basically. So I'm going to kind of copy over the switch statement, and I'm basically going to say, let's go ahead to instance init function. There you go. Now in the create info, we have flags there. Now I would say a switch. Ooh, what the? What happened there? Flags, just like, there you go, nice. Now, otherwise 0, but if it's one of these platforms, then I'm going to say vacate portability enumeration, I think. Portability flag bit. There you go. Vacate instance create enumerate portability bit kchar. Amazing. That are the flags. Now the other thing that we have to change to support macOS and other platforms like that, we need to go to the device extensions. Let's see, where is the device? Request device. There you go. So here we actually have extensions. There you go. kchar swap chain extension name. Nice. Now let's see. So can we actually say if, or let's add that switch basically. Now else we don't do anything really, but, or honestly we could choose simply to keep it comp time maybe. No, actually we cannot. Not sure, but let's just do this. Const extensions is equal to this guy, and then I'm going to grab this and put it inside of here. Otherwise I'm going to put it also inside of here, but I'm going to add that vacate let's see, portability. Well, it's gotta be the device enumeration thing. So let's see, vacate device extension. I don't remember the name of the extension of the device. So device portability extension Vulkan. What? Layers enumeration extension. Let's see. Let's have a look where it's actually talking about the device. Oh, what the? Why they're not including that guy? Ooh. I guess it's vacate portability subset. Portability, so there's these three guys. No. So there's this guy. I would guess it's probably just, you know, the same thing maybe. Yeah, I would try that anyway. Let's try that out. Not sure though about that one. Redeclaration of local constants. So no need for this guy. So basically, if it's one of the Apple products that are supported by Molten VK, we're going to add portability enumeration extension in both the device and the instance, and also we're gonna add the flag of portability in the instance. Otherwise, just the swap chain. And I guess that should be it. This should not change anything on other devices though, other than portability. But let's try now. I did see something about portability here. I'm not sure. Oh well, there's no portability profile thing or whatever that is. It seems like, but I don't know. I cannot really test it right now, seems like. But if anyone have a Mac OS or whatever, they can test it, hopefully. And yeah, pretty much we are done. We are done with the context. Well, almost. There's still this swap chain though. So right now we got created device, an adapter, an instance, and all that crazy stuff. So what's next is the swap chain. Okay, oh well. So const swap chain is equal to a struct. If there's any questions, let me know. fn init. So it's gotta be either in fact an error or self. Well, error or self. And then of course finally the init. Now a swap chain is kind of like the surface. It's recreatable. So you gotta recreate it when it's like, for example, when the window changes the size, and you also gotta recreate it, of course, when the actual surface gets recreated, and also when it gets outdated for whatever reason. So yeah, there's a lot of crazy stuff there. But anyway, self. I always find the recreation of the swap chain confusing, but I'll try to figure it out this time. Hopefully, we'll see. Okay, init, the init. Now, for the swap chain, I'm probably going to put it inside of the surface as an optional member. So it's gonna be like swap chain, and in fact, I think it probably would be created like with the surface at the first time, and then you can basically recreate it, you know. So anyway, basically the user will probably not handle the swap chain directly, I think. So yeah. So this is gotta be an optional swap chain, I believe. Unless maybe... let's see. I mean, maybe we could go with just swap chain. Not quite sure. We'll see. Okay, so what's next? But though, hold on. No, we need it to be optional, because the thing is, we cannot create the swap chain until we get the device. And in fact, we're creating the surface before creating the swap chain. We're creating the surface before creating the device, because in fact we need some information about the surface to create the actual device, compatible device. So it's kind of a cyclic thing there, but so we're gonna basically make the swap chain optional, and then when it needs to be created, we can create it. So fn recreate swap chain. Void. I don't know if it's gonna be void or error void. Probably error void though. Yeah, error void. Oh yes, exactly. Yeah. Interesting. So recreate swap chain. Now when the surface gets created, you gotta make sure to actually create a swap chain for the first time. So yeah, but there will be, I believe, maybe different versions. Or can we just have one version? I think we could just have one version, yeah. So basically, if swap chain, if there's already a swap chain, then we could do something about that. But anyway, whatever. So what we gotta do now? What we gotta do, let's see. Recreate swap chain. Well, I think the first thing that we have to do is to basically load the dispatch of the swap chain functions, I guess. Yeah. We need the structs for the swap chain extension, just like the one that we have for surface extension too simply. Yep, exactly. So let's have something like this, but instead, swap chain extension is not an instance extension, it's a device extension. Swap chain extension. So the dispatch we would go right now with, well, I guess destroy swap chain. cd.meta.child c.pfn vk destroy swap chain kchar. There you go. Now we got the destroy swap chain. Nice. Now we don't need an instance. In fact, we need a device because we gotta use the device for that. All right, Lloyd. Now instead of instance.vulkan_library.lloyd, we gotta actually say instance.lloyd this time. Device dispatch, there you go. Suffix also kchar, there you go. And then instance.handle. In fact, we also need create swap chain, isn't it? I mean, yeah, my bad. Okay. cd.meta.child c.pfn create swap chain kchar. Let's go. And I believe before that we even need something about surface capabilities, etc. I don't remember. Get physical device surface capabilities. Isn't that the case? Actually get surface capabilities. Get physical device surface capabilities. Let me search for that one. So this is the name. Come on. This is so annoying. Well, there you go. Can I just do this? There you go. Okay, there you go. So this requires a physical device, a surface, and it would give you the surface capabilities. We also need the surface formats. Get physical device surface formats. Formats kchar, I believe. Isn't that the case? Yes, and finally, I believe present modes. Surface support kchar. All right. And then finally, we need the present modes. Just like that. Amazing. So now we're just going to do something similar to this. And this, and finally this. Now we're just gonna change the names here. We just gotta give them these names and get physical device formats. and then present modes, and then create swap chain. So yeah, pretty much that's all the functions I think we need for now, at least. We do need some other stuff, I guess. I think we need let's see, yeah, acquire image. I think we need acquire image. So c.pfn vk acquire image. I'm not sure. Acquire next image khr. Yeah, I believe that's it. I believe this is part of the actual thing. Oh yeah, we also need get swap chain images khr. We also need qpresent. Yeah, we do need quite some stuff there. But anyway, for now, let's just, this is enough to actually create a swap chain and destroy, and that's what we need now. Although, of course, we do need to get the images, the swap chain images, though. Yeah. Yeah. All right. So I think I'm going to take a break for now and see you then. Just gonna take a little break. Hello everyone. Hello. I'm back. Skyville, are you still there? There you go. I'm here. Marty Flowers. See ya. Welcome back. Thanks. All right. So, any questions before we start, or before we continue, should I say? So far, as you've seen, we have created the surface and the adapter, all that crazy stuff. Now we need to create a swap chain. So we have made the swap chain dispatch, the swap chain extension dispatch, basically. Now, honestly, I'm not going to use the formats and the present modes just yet. I'm just going to try to use some stuff that is, like, for example, the present mode, I'm going to use FIFO, which is pretty much guaranteed, like per the Vulkan spec. But anyway, so for now, I'm just going to go with these guys. So yeah, let's get started. Create surface. What the? Oh, I see. All right, so let's remove this. So did we actually done this right? Hold on. Okay, instance Lloyd. Yeah, it's kind of weird. Hold on, what the? Why we have a Lloyd here? Oh, go back. Oh, I see what's going on here. So it just gotta be device.handle there. All right. Okay, great. But problem. Skyvale, have fun developing. I have to go to bed. Good night, man. Good night. Thanks for watching, and thanks for tuning in. All right. Well, to get that, actually, we need the surface capabilities. I forgot about that. So we need physical device. Not sure where to get that. Oh well, gotcha. Now the thing is, to actually create a swap chain, I need the surface and the device. Alright, current transform. And what else? Image format. Surface capabilities dot I guess format. Oh, I also have to get the surface formats. Interesting. So I guess let's get that. Well, how to do that? Well, do I have a function for it? Or honestly, for now, I'm just going to hard code it, I believe. For now, at least. Later on, we're going to change that. I mean, we're going to fix that. But terminal vacay yeah, I do not have one interesting piece of software that is useful, which is I don't remember which one have worked for me before, honestly. Well, let's try this one, I guess. Okay, hold on. All right. Let's go. Failure. Failed. Interesting. So let's try something else, I guess. That's unfortunate. I guess maybe this one. Seems to be good to go. There you go. That's what I'm talking about. Ooh, device can be uploaded to the database. Interesting. So we can upload it. Go to Taco. Submitted again in a live stream. What I've done basically right now is that I submitted it to the database. And the database here, if you don't know already, you can actually find a lot of reports from other devices basically. So you do not have to, let's say, buy some GPU just to know its Vulkan properties and capabilities basically. So yeah, let me make sure to have my chat. Where's my chat? Hold on. Oh, I see what's going on here. Okay, there you go. Nice. Let me actually put this guy here. There you go. Nice. So for example, there you go. Here's my card, I think, isn't it? Yeah, pretty much. I have just submitted it just now. There you go, Manjaro OS. Nice. Here is it. So that's the API, the driver, etc. Now there was some other submits of this, but look at that. My driver is 535, which I believe doesn't seem like it's here for whatever reason. So anyway, so this is my report that I submitted. Now anyone can actually go ahead into this database, and if he wants to look into this my kind of configuration on Linux platform with this kind of version, with this kind of device, they can check out the report that I submitted. And there you go. There you go. Amazing. So I recommend if you if you can submit your own report, then do that, just to help grow the database even more for people who are interested. Anyway, so now what I'm required to do now is surface, and let's see what, supported. Are these new or something? I mean, I do know that storage, but they wasn't here, I think. Anyways, whatever. So this is the surface formats that I could use. I could use UNorm or sRGB. I'd like to go with sRGB, so I'm gonna go with BGRA8 sRGB non-linear. I'm just going to basically hard code it for now. Later on, I may change that to do more robust kind of thing. But anyway, so image format is gonna be c.vk image format. Well, let's see, image format, BGR8. I don't know how do you actually BGR8. There you go, sRGB. It's a VK format, BGRA8 sRGB, then the image. Again, as I said, we have to actually do this much better using some other functions by querying the available formats and color spaces, etc. Right now, I'm just gonna hard code it. So color space, and then non-linear, I believe. What? sRGB non-linear. Right. So that's the image color space. What's next? There is clipped. Clipped, I believe it would be true. Well, it would be c.vk true. That's clipped. Usually you would like clipped to be on, but if you'd like to read the texture, even like, let's say another window is on top of your surface, then you'd have to make it false, but then you don't allow the operating system to kind of optimize things. But anyways, but usually you'd like to have clipped equal to true. What else? There is the image usage. Well, for the image usage, it's gonna be a color attachment bit, I believe, isn't it? Image usage color attachment bit, there you go. Because we're gonna be using our swap chain images as color attachments. Okay. Because we're going to use a render pass to actually render to them. So pretty much, other than that, there's also composite alpha. This one you could also query it, but I'm just going to go with opaque. Just gonna hard code it for now. Opaque. Well, VKO composite alpha opaque bit K Charlie. There you go. That's the composite alpha. What's next? There is minimum image count, maximum image count. These are interesting. I'll leave them until the end, I guess. Current extent. Current transform. Did I set the current transform already? Oh, in fact, that's another thing. Pre-transform, I set it to the current transform for now. Rage, present mode, I already set to that. All swap chain would be interesting later. Q family indices. Well, that's something interesting. Q family indices. How do you PQ family indices is equal to let's see, Q family indices. I'm not sure where it gets the count though. Oh, Q family index count. Interesting. So we need the Q family index count. There you go. And that's gotta be Q family indices dot len. And now just gotta create this little array here, const key family indices. It's an array of what? Of let's see, of U32, I believe. And here we're just gonna have one key family. In this case is the device dot adapter dot key family index. And there you go. There you go, there you go. Nice, nice, nice. What else? And old swap chain clipped composite key family index count image sharing mode. For the image sharing mode, you would basically, this is for concurrency, too simply. So like if you want to share your swap chain images between multiple key families, like to transfer ownership, etc., etc. Like for example, to present your swap chain images in one queue and then draw or render to those images in another queue, then you have to use concurrent. Sharing mode concurrent, but since I don't care right now about concurrency, I'm just gonna go with exclusive. Although a more robust way of doing this maybe is to say just key family indices.len. If it is equal to 1, then we're going to use you know, exclusive. So how to do that? Let's see. Equal to 1. Is there like a ternary operator in Zeek? I would guess so. Ternary operator Zeek. There you go. If, else. Alright, gotcha. Nice, nice, nice. So if this guy, so if it's equal to 1, then what we're going to do, we're going to say c dot you know, exclusive. Where is it? Sharing mode exclusive. Else we're going to say sharing mode concurrent. So basically if we have only one key family index, then we're gonna go with exclusive. Otherwise we're gonna go with concurrent. So that's one solution. Although I'm not planning on using multiple key family indices right now, but it's good to do already if we can. Anyways, image color, image array layers. Image array layers would be 1. You would only use this for let's see, for stereoscopic rendering. If you don't know what is stereoscopic rendering, let me have a look if I can find something real quick. I did indeed show this before, but I'd always like to remind people. Trying to find a good image. Oh well, here we go. We got a little images, some images here. So let's say, for example, you have some glasses, you know, which have like 2 images basically. So one image in one eye and the second in the other eye. So then you would basically use 2 image array. Like here you would say two image array layers basically. So you could use the same kind of I guess the swap chain for both eyes, kind of something like that. Hold on a second, I'm going to close the window. All right, back. Let's see. So, as I said, for example, you have 2 eyes or like 2 images, every image for one eye. There you go. Something like that. There you go. Look at that. So here you got your swap chain, and you have two image array layers, too simply. And you render for both of them, basically. So yeah, that's stereoscopic rendering, I guess, or stereoscopy in general. There's also some other use cases for these, but this is the main case. But usually you just use one. So yeah. Other than that, let's see what we got else. We got image extent, I believe. Now for image extent, we're gonna need to use the SDL, basically, to use SDL for this one. But let me find out how to actually create an extent 2D. Vacay extent 2D, and here you have a width and a height. So the width would be, well, let's actually get the width and the height. C.SDL, get, well, Vulkan, I believe. There you go, get drawable size. And here you too simply gotta get the window, and there the width and the height. It would give you the width and the height. They are cins. Okay. Var width, well, yeah, var width cint, and var height cint. And this could fail, right? No, it can't fail. Void. Alrighty, amazing. Now I could do simply say width and height. But of course, I think I need the window. What's going on here? Oh yeah, in the find. Now, hopefully I could get the surface, the window from the surface. Yeah, let's actually store the window on the surface. Why not? So we have easier time dealing with stuff. Where is the surface? There you go. Let's actually store the window here. I mean, we're getting it, I believe, isn't it? I mean, yeah, we're probably getting it where we're actually creating the surface. So where we're creating the surface? Yeah, I think here. Yep, there you go. So as you can see, we're getting the window here. So you could just, you know, put it in the surface so we can have easier time instead of every time trying to pass the window. We could just store it on the surface itself and call it a day. So yeah, I mean, in fact, we're gonna need that even in when we're going to recreate the swap chain. So yeah, we need that anyways. So window, let's see, window, it's gotta be a SDL one. No, it's gotta be our own window. There you go, and that's pretty much it. Done. Done. So let's go back to our swap chain. There you go. Cool. Now grid drawable size, surface dot window. Nice. Well, in fact, here I gotta say dot handle. Otherwise, what I could say, I could just too simply have cut this up and say get drawable size. Okay, and basically say, well, actually we could indeed say something like this. Window dot get extent. Something like that, I guess, or get drawable extent. Well, anyway, who cares? Get extent. Let's now go to the window struct, and now let's add a new function here. Get extent, well, self, and this would return vacay extent 2D. Okay, there you go. Now we would just to simply kind of get an integer here. Let's see, const, actually var with a cint equal to in the find, and var height cint equal in the find, and we're just simply going to return dot width equal to width and dot height is equal to height. And there you go. Now we do need, well, we already have the window, so we just gotta say self.handle. And there you go. So we have just created this little helper function too simply. Now let's go back to our actual code. Well, it's called get extent. Now I could basically use it directly too simply. Surface.window.get extent. And now what's else? There's color space, extent, format, usage. I already done all of that. Okay, well, let's see what else. There is surface, a minimum image count, image format, color space, image usage. Yeah, I think I've basically gone through all of this, and like only that now we only need the minimum image count. Now this is a bit tricky to get right. It's not that hard though, it's not that complex, but just a little tricky to get hard the first time, because there is some interesting thing that we have to be aware of. And in fact, let me show you from, for example, the Vulkan tutorial. There's a lot of resources where you can get code examples, but for example here, drawing triangle, you could go to presentation, maybe you could go swap chain, and let's have a look on where he's actually handling that. Minimum image extent. Oh, sorry, minimum image count. Oh, my bad, it's not that one. Oh yeah, well, it's actually minimum image extent, which I've already done, I guess, isn't it? Yeah, I guess so. Yeah, my bad. My bad. Well, right now minimum image count, I personally just set it to surface capabilities dot minimum image count +1. But I'm gotta make sure that I'm doing this right. Hold on a second. Vulkan surface capabilities. Let's see. Oh, that's 2. But where is just 1? Vacate surface. There you go. Where is the struct? There you go. Okay, let's check the documentation. So minimum image count is the minimum number of the image, the specified support for a swap chain, and will be at least 1. Alright, so there's no problem with that. The problem I think comes with current extent. There's some special thing there, and also maybe maximum image count. Yeah, I see. So maximum image count is the maximum number of images that the specified device supports for a swap chain created for the surface, and will be either 0, there you go. So this is a special case that I talked about. It could be 0 or greater than or equal to minimum image count. A value of 0 means that there's no limit on the number of images, though there may be limits related to the total amount of memory used by presentable images. Alright, max image count. Minimum image count doesn't have any problem. Interesting. So what we could say, I guess, is maybe we could clamp. Is there like a clamp function? No, there's no clamp. There is max and min though, but let's find out if we can find a clamp function instead. Okay. There you go. Let's get the value there. And now the lower. The lower is basically surface capabilities dot max. Well, the lower is actually minimum image count. But we're gonna be sure. mean, we're already using that, honestly. So we're making sure that's the case, really. So honestly, there's no need to clamp it. We could just say minimum. And now we do not need that guy. So the upper is surface capabilities dot minimum or maximum image count. Now the problem with this guy is if this guy is equal to 0, then we're basically going to say I guess std.math.big. No, let's find out. I don't remember. Max int, right? Max int, and I'm going to say u32 here. Otherwise, if it's not equal to 0, then we're just going to use that. Pretty much. And there you go. There you go, there you go. Nice. So basically, we're basically going to take minimum image count plus 1, and we're going to make sure that we don't go over maximum image count. So if a max image count is 0, that means there's no limit, so we're just assigning it to maximum integer of u32. Otherwise, we're just using the maximum that we got, pretty much. And yeah, that's pretty much it. The other one that I talked about is this guy, minimum image extent and maximum image extent. Now, we could deal with this, but honestly, there's no need since we have already fixed that by too simply not bothering with all that crazy stuff and too simply just getting the window extend directly. But I may change that in the future though. But for now, I think that should probably be fine. So yeah, I think right now we are done with the info, the create info struct. Supported usage flags, blah 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 blah, all of that craziness. Okay, now we don't need any of that. Okay, now we got the swap chain create info. Now we could create our swap chain finally. So how are we gonna do that? Well, self, I believe, .dispatch dot create swap chain, and let's have a look what it needs. It needs the device, which I believe we already have. It needs the swap chain create info, which we have just created. It needs the allocation callbacks, and it needs the swap chain KHR. Well, in fact, it's going to give us the swap chain KHR, right? So yeah, pretty much. Now, of course, it could error. So I'm going to say try map vk error, and then just going to put that function call there. And if there is any erroneous kind of error, it would tell us. It would basically go back and return it. Anyways, now create swap chain. We're gonna give it the device. So self.device. Oh, we already have the device here though. But what about self.device? Oh, interesting. Like, why we're getting the device here? Interesting. I forgot that we actually have the device inside of our struct itself. So we could just use that, right? So we only need the surface, really. Amazing. Now create swap chain self.device, well, .handle, because, well, we want the raw handle, not our own class. And then we want an address to our create info. I'm just gonna call it create info. Why swap chain create info there? Okay. And finally, well, not finally, but we need the allocation callbacks, which we're going to get as a parameter. Vk, well, allocation callbacks. Well, I forgot. C.vk allocation callbacks. There you go. Now this is gonna be a optional pointer. Now, honestly, later on, I may actually change these function signatures to, instead of taking the parameters, like I would make it take struct, so I could basically provide default values and all sorts of beautiful Zig stuff. but for now I think we're fine. And so that's pretty much it. And then of course we gotta get our handle of the swap chain. That's gonna be a handle in defined. Well, that's gonna be a c.vk swap chain kchar equal undefined. There you go. Nice. And with that, we should be able to create a swap chain. After that, hopefully we could return the swap chain object wrapped in our own class. Where is the class that we have created? There you go. Now this guy needs some fields. It needs, let's see, the extension, which is a swap chain extension. It also needs, well, extension, there you go. And it also needs its own handle. So c.vk, well, vk swap chain, there you go. And there you go, pretty much. I think that's all we need, pretty much. So in fact, I don't need an init function. We have already used the factory kind of thing. And then, and in fact, we could already do this. Maybe like we could say extension self.extension.dispatch.destroy swap chain, and here we could say self dot, I believe, handle, and then we also need the allocation callbacks though. Yeah, we also need the allocation callbacks. I may though need also the device. Hold on, let me make sure that we're doing this right. Yeah, we need the device first, then the swap chain, then the allocation callbacks. And we could easily get the device from the extension. So self.extension.device, and there you go. Amazing. And with that, we're done with the init function already. Now let's go back to our thing. So where is it? There you go. So here we got the extension first of all, which is basically self, and then we got the handle, which we have created, and then we got the allocation callbacks, which we got from parameter, and then finally, well, I think that's it, isn't it? Yep, pretty much. I believe that's it. So yeah, pretty much. I'll make sure that we have though an allocation callbacks. Oh yeah, we don't. So let's actually make sure to add that. So c.vk allocation callbacks. There you go. Nice. Nice. And I'm not sure why I put this swap chain thing very far away from its own class. So let's actually put it down there, or at least after the device, since it's an extension of the device. And there you go. Amazing. So now let's try it out. I don't expect it to work from the first try, but let's see. Swap chain. Now let's see. Const swap chain is equal to device dot create device dot. Oh, well, first of all, we need the swap chain extension though. Okay, swap chain extension is equal to try swap chain extension dot init. Oh, dot Lloyd. Yes, dot Lloyd, I guess. No, it's not. What the? Really? Hold on. So that's need the instance, and now let's go to the swap chain extension. It got a Lloyd here. Oh, interesting. It should get the device, not that guy. Okay, interesting. So device.handle like this. Now instead of the instance, we gotta get the device. And we don't need self. I mean, that's the one that's gotta create it. Try instance.lloyd. And in fact here I believe we need the device, not the instance. There you go. Alright, nice. So that should work now. So let's go back, Lloyd, and here give it the device. There you go. Now we loaded the swap chain extension with its own dispatch, etc., etc. Now we gotta use that. So const swap chain is equal to swap chain extension dot create swap chain. Here you give it the surface. Oops. Well, there you go. And then the allocation callbacks, which is gonna be null in my case. Where is the surface? Oh, well, interesting. So now we gotta create this surface. Oh yeah, so honestly I'm going to do this, I believe, in the surface, right? So I'm going to create it in the surface, I guess, because it gotta be recreated with the surface. Yeah, pretty much. So here in the surface where it is. Oh, what's going on here? Oh, where's the divide? Oh, where's the instance? Interesting. What? So there is an adapter there. Does that contain an instance? There you go. And the Lloyd device dispatch. All right. So you could say device dot adapter dot instance dot Lloyd. Okay, amazing. Now what else? Yeah, I don't remember where I was going. Let's grab this guy. So of course the swap chain extension we gotta create it ourselves, and then in the surface, bruh, I need a train to navigate this. Okay, so const swap chain. Now swap chain extension, we need that. And swap chain extension. Okay, and then now that's kind of tricky to actually load that guy. Let's see. I think honestly, let's just go ahead and just keep them separated for now. Later on, it may be great to actually put them in the same place. But anyway, because it's kind of getting a cyclic dependency there. So I don't like that. So what we gotta do now? Swap extension, const swap chain. Here we got the surface. Yeah, maybe surface. Well, here we gotta basically say, in fact, we're gonna have like, oh, I see. So this would be an optional swap chain, isn't it? And then basically if not Android, then we could already create the swap chain. Yes, so if that guy, or in fact we could too simply say if maybe surface, if we have the surface already available, then we could indeed go ahead and create the swap chain. Pretty much. If maybe surface, swap chain extension, create swap chain, and then the surface. Amazing. Now the same kind of similar thing here. We gotta say maybe surface equal try. Okay, so this would be a little bit more crazier. So we gotta do something like this, And in fact, I'd like to basically say const surface is equal to that guy. Now maybe surface is equal surface, and then finally maybe swap chain. Ooh, well, that gotta be a maybe swap chain there. Maybe swap chain. If maybe surface, create swap chain. And that returns a swap chain, right? Yes, I guess. And then there you go. Now maybe swap chain is equal to the, well, pretty much the same exact thing. And there you go. Maybe swap chain equals swap chain extension, create swap chain. Amazing. If maybe surface, now we'll enter background. Now if it's will enter background before deinitializing the surface. And oh, talking about deinitialization though, we gotta do something similar to this guy. So let's see where we have the swap chain. There you go. Defer if maybe swap chain dot deinit, and there you go. Amazing. Now that's one thing, and the other thing is that before we deinitialize the surface, let's make sure to deinitialize the swap chain. And there you go. Oh well, maybe swap chain. Well, maybe I could say, I don't think you can. I don't think I can, but I could say just maybe swap chain dot, or I could too simply say if maybe swap chain, then to simply then do maybe swap chain dot deinit, or sorry, swap chain dot deinit. Let's go. Amazing. So if there is a swap chain, then we're going to deinitialize it first, then we're going to deinitialize the surface. Does that make sense? Yep, I think so. And here, creating the surface, then we're creating the swap chain out of it. Pretty much. It's kind of weird that, like, it's kind of annoying that we have to always like remember like how to actually deal with that stuff. But anyway, so I think this should be good to go, hopefully. I don't expect it to work from the first try though. Let's see. Okay, has no member named fake k swap chain. KHR, I forgot about that. I don't know why ZL stuff didn't tell me about that, but anyway. Struct declared here, missing struct field swap chain. What do you mean swap chain? Oh yeah, I actually abandoned that idea of embedding the swap chain to the surface. So what else? Missing struct field, create swap chain. Ooh, I think I forgot something. Create swap chain. Yeah, this should be undefined by default, so we could actually do that trick. Maybe we could change that later on to a better solution, I guess, but anyway. So expected type u32 found cint in the width. Well, I guess int cast. Int cast, and there you go. I guess in SDL3 they will change that later on to be uint instead of cint, like u32, sorry. But yeah, no field named handle in swap chain extension. Alright, well. Oh, why we have self there? Okay, there you go, swap chain. Cannot assign to constant. Oh yeah, it should be variable. And zig build run, again another error. Expected main.swap chain found union. Oh, gotta try that up, and then I gotta also try this one too. Yeah, pretty much. And expected type found main.dev. Oh yeah, we gotta do handle there. And I guess we got a runtime error. Scary. Index out of bounds. Index 2 len. Ooh. Index out of bound. I guess -1. Error is still SDL Vulkan create surface. What? The question why? Create surface. That failed. Well, that's interesting. Why? Okay, let's find out. Well, print, I guess. Or let's actually try and maybe say SDL log error. Let's see. Hopefully we're gonna get an error there. So c.sdl. Otherwise we gotta dig on the actual source code, which won't be so fun. Anyway, SDL category error. Sorry, application, and then fmt. Well, s. Then here c.sdl. Not sure if that throws an error, but we'll see. Find out. Okay, vkchar xlib surface extension is not enabled. Ooh. Yeah, I pretty much got it wrong. Hold on a second. Makes sense. Okay, I see what I've done there. Alright, makes sense. Alright. Extensions. Other than that. There you go. So it's indeed like this. But the thing is, I should make sure we are in the right platform. So in fact, if additional extension count is equal to, well, greater than or equal to 1, I guess. This is kind of hacky, honestly. I should probably make this into an array list and then use that. But hopefully this should work still. And error, get device proc addr for some reason. So it get device proc addr, so it actually failed to get some device and name. Interesting. Can you print real quick the name? Let's find out what is the name. I should make more better error handling. Yeah. Okay, vacate get physical device surface capabilities khr. Ooh. Well, I guess I know what's the problem. Vacate get physical device. What? Interesting. Vacate surface capabilities khr. Let me make sure the name is correct. The name is correct. I think now what's the real problem here? Get device proc addr. Let's find out. Interesting. Oh, well, no. Get device proc ADDR. Right. Where is that guy that we're looking for? Kit physical device, surface capabilities, PFN, KHR. So it's part of the swap chain extension. Well, maybe it's part of the instance though. Yeah, maybe. Let me find out which extension that's part of, because it could be from the instance, not the... Yeah, really. Yeah, probably, in fact. Probably. Interesting. So let me try to get this out of this guy. It seems like I mistaken the extension. Hold on. So instead of putting this in the swap chain extension dispatch, I think I should probably put it in the instance. In the surface, maybe? In the surface extension instead, I would guess. Okay, what if I put it here? I think that was the problem. Probably. Let's find out. Self.dispatch, not self. Now it's gonna be, well, self, in fact, surface. The extension, I believe. Hold on. Surface dot extension. There you go. Dot dispatch. And let's try this out. And there you go. We fixed it. Amazing. Amazing. So I think right now we have indeed a swap chain, but we're still not presenting anything, of course. So yeah. Now let me just make sure we have no validation errors or whatever. Yeah, we have no validation errors. Let's make sure we're calling the right stuff with the right parameters. So let me use the API dump layer and let's find out how everything is going. Okay, 800, 600 returns VK success. So as you can see, we're indeed creating the swap chain amazingly. Nice. Nice. And what happens when I quit? There you go. So as you can see, instance, destroy surface, device, swap chain, and yeah, pretty much amazing, lovely. So it seems to be all good to go. Minimum image count is 3, which I believe is triple buffering, possibly, not sure. Anyway. So yeah, pretty much we're good to go, I think. One little thing is that maybe I'd like to put maybe some helper function in surface to actually get the physical device surface capabilities. Yeah, I think that would be nice. So let's actually do that, I think. So instead of doing this craziness right here, you would hopefully only have to do get physical device surface capabilities, get capabilities. Oops. Get capabilities. There you go. So now let's go to the surface, I believe. So you have to give it the physical device. You don't need to give it the handle. And in fact, you pretty much don't need to do this weird stuff. You just gotta give it the physical device. Oh, in fact, do you really need to give it the physical device though? Let's see. Maybe you need to give it the adapter. What does surface have access to? Yeah, only the extent in the instance. Interesting. So in fact, so let's go with the adapter, I believe. Yeah, let's go with the adapter. And pretty much that would give you the surface capabilities directly, hopefully. So surface capabilities equal to this guy. Amazing, perfect. So now let's actually create this capabilities function. So surface, go to surface, there you go. Now fn get capabilities, there you go. Here you gotta give it an adapter. So adapter, how are we gonna deal with that? Well, adapter just like that, and then you basically gotta give it vk surface capabilities khr. There you go, nice. Now what we gotta do is we gotta use self.dispatch dot extension. Well, we need self first of all. Amazing. Okay, so self dot extension dot dispatch dot okay, physical device surface capabilities, and you have to pass to that again. I forgot. You have to pass to it the physical device, the surface khr, and there you go. Okay, so the physical device. So it's basically adapter.physical device, and then what else? Self.surface.handle. Oh, actually it's self.handle, right? And then here it would basically give me the surface, the surface capabilities, which basically are capabilities. And yeah, there you go. Var capabilities is c.vk surface capabilities khr, there you go, equal to in defined, and let's go. Now of course this could fail, isn't it? Let's find out. And yep, this could fail. So we're just gonna say try self dot map vk error, and there you go. You just gotta do this, and let's go. Now after that you just return capabilities. Now of course this could error too simply, and there you go, we're done. We have created this little helper function there. Amazing, perfect. Now let's go back to where we're using this capabilities function, and in fact in this case we don't need this map vk error anymore here, and let's go. Much cleaner that way, much cleaner, and it should be working out now. There you go. Amazing, perfect. So right now we created the surface. Now we gotta actually let's see, get the images from the swap chain, and then to create the image views out of them. And with that we should hopefully be finally done, kind of, with the context. So that's a lot of crazy stuff, but there you go. Man, another level. It's already 517, and I'm still creating the context, like what is equivalent to the OpenGL context. Oh my god. Let's go. But you know, it's cross-platform, hopefully. In theory it should be cross-platform, but of course I'm not claiming that I'm very knowledgeable on Vulkan, but I just know enough, hopefully. So there you go. Okay, is there any questions until now? Let me know if you guys have any questions. hold on a second, I'm coming back now, just a second. All right, back. So, Marty Flowers, is there a Vulkan? Is the Vulkan lib a binding or the C API? Well, let me just. So here I'm using. So I'm basically just including the C headers of the Vulkan API. But the C headers just, give you the declarations, the types, and stuff like that. But the thing is, right here, what I'm doing is when I'm actually loading the Vulkan library here using SDL, because, well, SDL takes care of loading the dynamic library for me in a cross-platform way, so I do not have to use these system libraries, basically. So let me show you. So here, this Vulkan library struct, okay? So when I say SDL Vulkan load library, now SDL goes ahead and tries to figure out in a cross-platform way to actually load the dynamic library of Vulkan, using its names, etc., etc. So for example, let me actually show you the documentation of that. Let's see. There you go. There you go. So they should be called after initialization. Okay, it is finally common. Okay, so I just noticed you use Brave. I do as well. All right. So as you can notice here, it's actually trying to basically load the Vulkan dynamic library. And for example, here on Mac OS, I think, hold on, SDL would attempt, there you go, SDL would attempt to load vulkan.framework/vulkan libvulkan.1 dlib moltenvk.framework/moltenvk and libmoltenvk.dlib. These are basically the names that SDL tries to load on Mac OS, for example, like the dynamic library names that it tries. And of course for Windows it tries, I think, let's see, vulkan-1.dll, etc., etc. So basically it loads in the Vulkan library as a dynamic library. But the thing is, the Vulkan library that we load in isn't, a library, because in fact Vulkan is not a library. It's what we're loading is just the loader of Vulkan. Now Vulkan is a spec, is an API. The implementation is done by each and every graphics driver, basically. So for example, NVIDIA have to implement the Vulkan API for their own graphics cards, etc. AMD, same thing. Intel, same thing, etc., etc. So each one of those implements the Vulkan API for us. And here, when I say load library, I just load the loader, just the one that I could basically take from the. So here, as you can notice, well, where is it? It's called get instance proc addr. Okay, so this function, if you can notice that I'm actually loading one symbol from the loader library that I loaded, which is get instance proc addr. That's the only thing I need, the only symbol I need from the loader library. I get that, and then I use that in a cross-platform way to basically load all the other Vulkan functions that I need. And basically why I do that, I mean, I could just use the loader directly statically, but every time I call a Vulkan function, the loader have to go ahead and figure out which driver I'm trying to reach, which, etc., etc. So it needs to basically redirect me to the right path, to the right functions, to the right implementations every time. Now that's a bad thing for performance, because every time you you call a Vulkan function every time you have to go through the loader, and the loader is kind of like a dispatcher. You know, he have to figure out which path it needs to do to figure out the right driver, etc., etc. Yeah, like the entire library is a virtual function. Yeah, exactly, kind of. You can think about it like that. So that's why what I'm doing is that for every instance, I'm loading the actual function pointers for that specific instance, okay? So if you figure out here, dispatch, there you go. I'm actually loading those functions for that specific instance. So right now here, I may actually remove one redirection, you know, and then afterwards, later on, when I come to the device, the Vulkan device, where is it? There you go, Vulkan device. Again, I'm removing one other redirection from the loader. So here at this point, when I load device function pointers, at this point I'm calling directly to the driver. I'm getting exactly driver functions directly. So right now when I use, for example, destroy device and get device queue and also the swap chain extension stuff, although swap chain is kind of an exception because it could still go through the loader because there's some you have to interact with the operating system, but that's just an exception. But essentially most device functions that you load in using get device proc addr, they're basically you're loading functions directly to the driver. That's it. Like, you have no middleman at that point. It's just you and the driver directly, as long as you didn't actually enable any extra layers. Now in my case, I do indeed have some layers enabled. Like for example, when I do the API dump, now instead of loading directly to the driver, I'm loading into the API dump, and then the API dump directs me to the driver. So I have one extra redirection since there is a layer that is enabled. Now I could enable multiple layers, and now it will basically be a chain of calls, and every time you basically degrade your performance more. But in a release application, you would basically not enable any layers at all, and at that point you're basically calling directly into the driver with no middleman, no overhead, nothing. You know, application driver, that's it, done. No crazy stuff going on. And that's the way it goes basically. But most people, at least in tutorials, they usually just either just statically link to the Vulkan loader, which is the dynamic library, and just use the loader directly, and they don't mind basically that redirections, although they're losing performance right there, but it's much easier to not, you know, create your own dispatch tables, etc. Like a lot of the work that I've done was mainly because I have to kind of go ahead and load the function pointers myself, etc., and use those, etc. So that was a lot of work. Otherwise, you could use a library. You could use some libraries. Like the most popular one though is Vulk. This library, right? Well, man, Vulkan, I have no idea what's that. Anyway, so this library right here, it's Vulk is a meta loader for Vulkan. It allows you to dynamically load entry points required to use Vulkan without linking to vulkan-1.dll or statically link in Vulkan loader. Additionally, Vulk simplifies the use of Vulkan extensions by automatically loading all associated entry points. Finally, Vulk enables loading Vulkan entry points directly from the driver, which can increase performance by skipping loader dispatch overhead. There you go. By skipping loader dispatch overhead. Vulk is written in C89 and supports Windows, Linux, Android, and macOS via Molt and VK. So you could use this. This is a C library that allows you to do basically the same thing I've done. But the problem with this library though, it's basically the same exact thing. But the problem with this library is the fact that it loads the function pointers in the global scope. So if you don't like global scope, and also one other problem with that is that it assumes that you're going to only load one instance at a time. So if for whatever reason you want to create multiple instances in your application, for whatever reason, you just cannot. You have to do something about it other than that, because it's basically global scope. And let me actually go ahead and close the window. The dogs are annoying me. All right, back. So I think hopefully that answered your question. Hopefully. It's kind of hard. I didn't really figure it out until, like, it took me some time to figure out how everything works, especially this kind of Vulkan and what it does. So yeah, you just say Vulk initialize, you know, and if it was successful, it would basically load the function pointers of the, yeah. Nah, actually, Vulk initialize would go ahead and load the dynamic library, and of course it would use the global scope though. And Vulk load instance, you basically give it the instance, and then it would go ahead and load the instance function pointers, and then optimizing device calls. Then you could use Vulk load device on the device that you have created to actually load the device functions too simply. You could also use this guy right here, but pretty much I've done all of that stuff myself manually, and with that I get the added utility that I have full control over how everything is structured, and I have no global scope stuff. And it's all like, if I want to create multiple instances, there you go, create multiple instances. If I want multiple Vulkan libraries for whatever reason, I can. Pretty much. And the other thing that I'd like to mention, since we're talking about function pointers, is that if you noticed, I actually defined VKNO prototypes here. Now, if you're going to statically link to the loader and use the loader directly, you shouldn't define this, because you won't get the the function pointers loaded in. But since here I'm not using the actual global function pointers, like I'm not statically linking to the loader, I said VKNO prototype, so it doesn't generate function definitions. It only gives me the types of the pointer function types. Like here it is. Where is it? Like all those c.pfn vk. Yeah. So it just tells me that the pointer function. It just tells me the types of the functions. It just generates the types of the function pointers, not the actual function definitions. That's why I said VKNO prototype, so it doesn't generate definitions, only types. And yeah, pretty much. That's pretty much it. Hopefully that made sense. And yeah, pretty cool. Pretty cool. Okay. Is there any other questions? Okay, so I think we should continue now. Now we pretty much need to get the swap chain images, right? Swap chain images. So let's see. Swap chain is equal to struct. There you go. So I didn't do for quite a while, but let's see. Okay. Which functions I need, first of all, to actually load. Where is it? And also one other thing that I kind of forgot to mention is the fact that there's one other thing that I've done, is that I separated the extensions from the core functions. So with that, I have a more modular and extendable structure to my program. And also that allows me to, for example, have some optional extensions. For example, you know, like if I couldn't find the swap chain extension, for example, I could basically go without it without any problem, like not load the function pointers at all, because I can't if it's not available. So I don't even bother to do that if that was what I want to. Basically optional extensions. And yeah, and it just stays in its own kind of struct thing. It's like it's an extension, just like that, basically. Hopefully that makes a little bit of sense. Anyways, so now let's go ahead to the swap chain, I believe. Dispatch. Okay, now let's add another function. vk, I believe, get swap chain images. There you go. Swap chain images khr. One other thing that I've done, thanks to Zig's comp time stuff, is the fact that I don't have to every time use vk and then say khr at the end, etc. I don't need those because I kind of just process that at compile time and add those. There you go. So here I said the suffix khr and it just does that stuff for me at compile time. So that's pretty amazing. Okay. cd.meta.child equal to undefined. There is still a lot of crazy stuff that we could do with Zig comp time to actually make a lot of things much easier. But the problem, the more comp time stuff you do, ZLS goes crazy. You lose on like intelligence, basically. So yeah. All right, get swap chain images. So now let's actually get the swap chain images. Nice. Let's see. So after creating the swap chain, we could get the images. So let's see, self.dispatch. Yeah, get swap chain images. Now let's find out the type of this guy. Oops. Okay, so you give it the device, the swap chain, and then what is that? A U32. Oh, yeah, gotcha. It actually gives you the count, and then you could basically allocate memory for the array, of course, not the actual images. The actual swap chain images are actually allocated by the operating system, pretty much, and then you could just fill in that array with images, pretty much. Amazing. So let's actually go ahead and do that. Let's see. Get swap chain images. So, and one thing that I actually kind of forgot is the fact that, for example, what's gonna happen if, yeah, what's gonna happen if there is an error after creating the swap chain? Then at that point I'm going to leak the swap chain memory, like the swap chain handle. So what I should actually do to make sure that doesn't happen, I should make sure to say error defer and basically do something like this here. So extension, well, that's gotta be self.dispatch.destroy swap chain, self.device.handle, self.handle, self.allocation callbacks. Right? Yep. So even if I return from this, it would be just fine. It would go ahead and clean up the swap chain handle. Amazing. So it seems to be working just fine. Lovely. Now let's actually say self.dispatch get swap chain images. So try map vk error. There you go. Get swap chain images. Again, what I need the device and the swap chain. So self.device.handle and then handle, pretty much the swap chain handle, and then here we gotta say count swap chain images, or just images count, right? and then afterwards you could just say null. Now of course we gotta have count here, var images count, which is gonna be I believe e32. Yes, equal to indefine. There you go. And now it's gonna tell me how much images there is, which I believe would be just basically the one that I passed actually to minimum image count, I believe. But well, in fact, that's just the minimum image count, but the implementation could decide to add some more images, maybe, I guess. So anyway, either way, you just say images count, there you go, and you just use that. All right, amazing. So how are we gonna do this? Well, const, we need the allocator though. We need an allocator at this point. Yeah, we need an allocator. Let's see, allocator. So cd.mem.allocator. So const images is equal to allocator dot alloc. Com time t type is c dot bfn vk. What I'm doing? No, c dot vk image. There you go. And new size, which is the count, images count. There you go. Lovely. Of course, try this out and error defer. I probably forgot about a lot of error defers, so I should probably revisit all my code to make sure I don't have any leaks when an error happens. So yeah, but anyway, error defer. It's not the end of the world though when when that happens for an error, but you know, you gotta be perfect. Anyways, allocator.free images. Let's see, allocator.free images. So now we got the images. Amazing. Well, we got the images array, but now we should also, of course, recall the function, and now give it the actual allocation. Well, images.ptr, and that should do the trick. Try map vk error. Yep. Now what's next? Yeah, pretty much right now we got the images. Now we just gotta wrap them in image views. Pretty much. And after that, we're gonna need to create frame buffers. But frame buffers, I think if I remember well, requires a render pass. So you need a render pass first to actually create frame buffers. But yeah, right now we just gotta have another step to basically finish up, I guess, at least with the creation of a swap chain, which is image views. So let's find out how we can do that. Well, first of all, we gotta actually allocate an array for them. Now, let's see. Okay, const image views. All right, so images, well, actually let's go with views. Hold on a second, I'm gonna come back in a sec. All right, back. Okay, so const views is allocator.alloc com time t type is, well, c.vk image view, and n is the images count. And there you go. Now we allocated some memory. Of course, again, error defer allocator.free views. There you go. Amazing. Now what we gotta do next is basically for each and every view. So for views, view, isn't it? Now of course we're going to actually, yeah, we're going to change that. So let me make these a references, like reference capture, kind of mutable capture basically. Now what we could say is view equal to, now we gotta actually create the image view. So I don't actually remember how. Let's see. Do you just like create? I think you just create a struct, isn't it? No, you actually use some function, right? So let's find out about that function. vk image create image view. There you go. So I need to load another function called create image view. Okay, where is it? There you go. Create image view cd.meta.child c.pfn. Oops. Create image view. Well, don't you need khr or something? Really? Really? So it's a core function. Are you kidding? Oh, well, that makes sense. Yeah, that makes sense. So this shouldn't be here, really. Yep. This shouldn't be here. So we gotta actually put it in... where? I think device. Probably. Yeah, I think device. Hold on. Yep, device. It's a device function, core function. So where's the device? There you go. We got a new function. Amazing. Indefined. Create image view. Now we could use the device to do that too simply. In fact, we could add... Oh, interestingly, we don't have any helper functions yet in the device. So there you go. I guess create image view, and then it's probably either an error or a vk image view. Oh yeah, there you go. Now self.dispatch dot create image view. Now let's find out about this guy. Could it error? Yes, it could. And then it basically needs the device, which we already have, and info, which we're going to get, and then allocation callbacks. Okay, vk image view. Oh, see, interesting. So we're going to say vk map vk error, and then we're going to simply say create image view, and then we're going to pass in the device handle. Ooh, yeah, that's why. So self, then self.device.handle. There you go. Next up, you would need to pass in allocation callbacks, isn't it? No, the create info, and then the allocation callbacks. So create info, and then the allocation callbacks, and then finally the output variable, the output reference. So for that, we're gonna need image view, or handle too simply. So var handle, it's gonna be a vk.image view, oops, c dot vacay image view equal undefined. Now we're going to return handle. But of course, let's try this out since it could fail. And there you go. Now we need to create info. What I'm doing, c.vacay image view creates info. That's the create info. We also need allocation callbacks, of course, which is c.vacay allocation callbacks. Although we could maybe use the device callbacks instead, but anyway, right. Now what else? Allocation callbacks. Yeah, pretty much that's all we need, I believe. Yes, exactly. So that's all of it. Create image view. Now let's go back to our swap chain stuff. Now we could, instead of this, could too simply say device dot create image view, and here we gotta give it the create info, and here allocation callbacks, which is gonna be null in my case. And now let's fill in the create info. Alright, that's gonna be interesting, I guess. Let's see. Let's grab this guy and let's paste it here for reference. Okay, amazing. So, well, first of all, of course, as always, we need the S type is equal to c.vacay st structure type, and let's go with image view create info. And what's next? P next. Well, honestly, I'm going to use that std mem init 0, I think, or something like that. Flags, image view type, format, components. Yeah, I guess maybe. So let's actually say std.mem .init 0 init, and then here the comp time type is the vacay image view create info. There you go. And now the init. Well, is type c.vacay structure type. Oops. Image view create info. There you go. And now that's the S type. Now what's next? P next, basically 0 flags, I would guess 0 image. We have it here. Oh, interesting. So we gotta basically, I think, ooh, interesting. So we gotta actually use a new feature of Zig. You can basically give it like multiple kind of slices, for example, and then it would loop through both. So in this case, it would be image like that. So, and now here I could just say image. Pretty cool, isn't it? Okay. Nice. View type. I don't know though if it does work. Never tried it before. We'll see. View type vacay image view type. What's even that? Oh, I see. 2D. Well, it's gonna be 2D, of course. That's a swap chain image. And then we got the format. We're gonna use here the swap chain format, pretty much. And luckily we already have create info, so we could just use that instead. Format, image format. There you go. And next up we would have components. the components. For that, I don't remember. We'll see. C.vacate components swizzle. Oh, for that one, I'm just gonna go with identity. Swizzle identity. I guess that's 0. Yep, it is 0, so we could just leave it out. We don't need to specify it. For the sub-resource range, we need the c.vacate sub-resource range. Vacate image sub-resource range, alright. And here we need, let's see. So we need the aspect mask. Okay. Let's have a look into the aspect mask. Is equal to dot. Oh, well, c.vacate aspect. Oops. Color bit. Okay. Because we got to use that as a color target. And then we have the base array layer, which probably going to be 0. Base MIP level, I guess, same thing. Layer count, level count, maybe 1. Yeah, maybe 1. But let me have a look. Where is it? There you go. Oops, not this guy. Let's go to registry. Okay, so base MIP level is the first MIP map level accessible to the view. Level count is the number of MIP map levels starting from. Base array layer is the first array layer accessible to the view, and layer count is the number of array layers accessible to the view. But what is the valid usage? Okay. Vacate remaining MIP levels array layers. If aspect mask include, must not include any if. And then aspect mask must not include, okay. Must be a valid combination, must not be 0. Okay. So I think base array layer would be 0, base MIP level would be 0. And base array MIP level 0. And dot layer count would probably be 1, I would guess, and level count would probably be 1. And hopefully that's it. I think. Yeah, I think that's probably it. Yeah. Okay, let's find out. But of course we gotta store this stuff up. So images is equal to images, and finally image views. Well, views is equal to views. Yes. And of course these are allocated, so they got to be deallocated afterwards. But anyway, so this would be a slice of c.vacate image, and then views would be a slice of c.vacate image views. Vacate image view, okay. Amazing. Now we got that out of the way. Nice. Okay, what's next? So we gotta make sure to actually deallocate those arrays on the init function, and also to destroy the image views. But for now, let's just try to see if this actually works in the first place. Member function expected 3 arguments, found 2. Makes sense. We gotta add an allocator now. Yeah. Oops, what happened there? There you go. Okay, there you go, nice. Where's that guy again? So where we're creating the swap chain, we're creating it here again. Nullicator. What? Nullicator? That is a very cool name. Nullicator. No way. No, it was nullallocator. Nullallocator. Honestly, that's a very cool name. Please don't steal this one. Alright. That is very great. I think I'll probably call the project that, really. That is very interesting. Honestly, that's very cool. So, yeah, we'll see. We'll see about that. That is a very cool name. Okay, well. Great. Now let's try to see if this actually works. No field named handle. What? Oh yeah, because you gotta say handle here. Yep. And no field named allocation callbacks. Well, interesting. It's gonna be allocation callbacks. Ooh. Let's go to create image view, and this guy should be a pointer, an optional pointer. And let's go ahead and run this up. Unexpected, blah 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 blah. Now this could return, I believe, yeah. So let's try this out. No field named device. So no field named device in struct main.device. Oh yeah. Well, self.handle. What else? Yeah, there should be an address of. And finally, we got it working. Right, amazing. Now, of course, we have a memory leak, as you can see. Memory address leaked because we still haven't actually deallocated those arrays. So let's make sure to do that. And also we're leaking the image views, so we gotta also destroy those guys. So let's go ahead to the swap chain. And now in the DNets, before or after, hold on. Yeah, before destroying the swap chain, let's first of all start by, well, the last thing we're gonna start with, I guess. Yeah, which is to simply destroy all the image views. So you gotta loop through all the views, and then view, and well, of course, self.views. And well, we need another function in the device though. Device. There you go. So let's add another function called probably destroy image view. What I really love about Vulkan though is the fact that all names are consistent. So once you have gone through enough names for enough time, you start to kind of, just guess the name that you're looking for. So that's very cool. All right, lovely. Now destroy image view. So yeah, we got that now. And now let's go back to for views for self. Oops. For self.view. There you go. Nice. Now we're gonna do is self dot extension dot device dot dispatch dot destroy image view and destroy image view, isn't it? I don't think it probably need a lot more. Probably the device first of all. Yes, the device, the image view, and then the allocation callbacks. So the device is gonna be okay, self.device. No, the extension dot device dot, let's see, handle. And then view. And then what else? The allocation callbacks. So self.allocation callbacks. There you go. That's the first thing. Next thing is to basically deallocate the arrays. Of course, you shouldn't destroy the images though, because we haven't created them. Those are created, as I said before, by the operating system or whatever. They're not allocated by us, so they're not owned by us, so we're not responsible to destroy them. So we just gotta basically deallocate our arrays that holds those handles too simply. But for example, the views, we actually are the ones that just created them, so we own them, which means we have to destroy them. So after this, you basically have to say, well, we have to store the allocator though to do this correctly. So allocator is std.mem.allocator. Here let's pass in the allocator that we used here to allocate those guys. And here I'm just going to say allocator, allocator dot, self.allocator dot free, and I gotta give it self dot views, and then finally self.allocator dot free self.images. So of course here we're deallocating the arrays, not the actual images. So there you go. Lovely. So that should be good to go. So yeah, pretty much. And we have no memory leak. Amazing. Let's make sure that this is working on release. There you go. It's working on release 2. Amazing. Perfect. So now let's make sure we're calling the right functions and that there is no validation problems. Let's start by validation. Alright, yes, we got no problem with validation, which is amazing. Let's make sure the same thing with release. Amazing. Now I just want to kind of just go through API dump for a second, just to make sure we're doing what we're expecting to do. It's better be safe than sorry. Okay. So as you can see, we're calling create image view 3 times because we have 3 images. Lovely. And here, as you can see, we're getting the swap chain images. We're calling them 2 times. First time to get the count, and then the second time to actually get the actual images data. And then here we're creating the swap chain, of course. So pretty much lovely. Now when you actually quit, what happens is that we destroy the image views first of all. Then we deallocate the arrays, as you can see, and then we destroy the swap chain. Afterwards, we destroy the device, destroy surface, and destroy instance. Voila! There you go. Amazing. So, and with that, we have finally finished the swap chain creation. But though we still have to recreate the swap chain. Oh well. Still have to recreate the swap chain. Okay, and that's not a big deal though. That's not a big problem. It's kind of a little hard to get right. A little tricky though, not hard, but yeah. So I don't need these comments anymore. And this is a very nice feature. I kind of basically loop through images and also loop through views. For the images, I'm just reading from it. For the view, I used a reference or a pointer there to actually be able to write to it. So basically a mutable kind of, loop or mutable iterator kind of thing. But yeah, that is very nice, very interesting, lovely. So yeah. Now, one other thing is that we could add here is old swap chain. Now, this should be optional, I guess. Old swap chain, Wiki swap chain KHR. So here we're just gonna add old swap chain. Okay. Old swap chain. It's gonna be a Wiki swap chain KHR. There you go. All right, amazing. Or in fact, what about, let's see. Well, can't we actually say swap chain? Just use, yeah, okay, sure. Sure. Now we're just getting this, the whole swap chain, right? So old swap chain. Now basically old swap chain. Now if old swap chain is not equal to null, then basically give old swap chain dot handle. Or hold on. Actually, this should be optional, right? And I'm going to call this maybe old swap chain. Okay, maybe old swap chain. Now if maybe old swap chain, then at that point we get the old swap chain. And we're going to basically pass in the old swap chain. Else, we're going to pass 0 or null or whatever. 0, well, probably null. Not sure. Maybe null. Anyway, so if maybe old swap chain, then, well, you get old swap chain, else null. Let's see if this would actually compile. And yeah, we have to add now a fourth argument, which is the old swap chain. In our case, it's gotta be null. In this cases. And yeah, maybe surface, pretty much. Let's see if this would compile by any chance. Cannot cast into optional type child. Let's see. Oh yeah. I think I know what it's talking about. So let's go to old swap chain. Old. What? Oh, I'm searching through that one. Okay, old. Oops. There you go. Okay. So it probably should be 0 here. Where is it? Here. Probably 0, not null. Ooh. Well, actually not 0. C. If I remember, maybe c.wiki null handle. Incompatible types. Oh, alt swap chain.handle. There you go. And what's the problem here? Yeah, I guess maybe it's null. Weird. There you go. Okay, null. And that's pretty much it. So if there is an alt swap chain, we're given the handle of that swap chain. Otherwise, we're getting null. Now, there is some other considerations that we have to take into account, but honestly, I'd rather go into the documentation because it's kind of weird. AK create swap chain. Now there is a tutorial though. Not sure if he's using alt swap chain. We need to pass, so it is possible to create a new swap chain while drawing commands on an image from the alt swap chain are still in flight. You need to pass the previous swap chain to the alt swap chain field in this vk swap chain create info thing. Struct and destroy the alt swap chain as soon as you've finished using it. And destroy the alt swap chain. Okay. Interesting. So after doing that, I guess after creating the swap chain, then maybe we could basically destroy our current swap chain, or the old one, I guess. So basically maybe old, well, of course, if maybe old swap chain, and though let's actually leave that error defer there. Now if that's the case, well, honestly, we could do a bit of an optimization here. Is that since there's gonna be probably the same image count, then we could probably just reuse the allocations of the arrays. We could probably reuse those. Yeah, there's some pretty interesting stuff there. Interesting. But for now, I'm just going to keep it very simple and just going to redo everything. So if maybe alt swap chain, you know, we're just going to go ahead, alt swap chain.dinit, too simply. For now, later on, I probably could look into it and see if it would be possible to reuse the arrays that we have already allocated, so we don't have to allocate once again, and that would be nice. And maybe the allocator could also be optional at that point, like if you passed in an alt swap chain, then you don't now have maybe to pass in an allocator or something like that. But anyways, whatever, who cares. So I think this is all good to go for now, hopefully. Alt swap chain dinit, and then we basically create the new swap chain. Amazing, amazing. Although we gotta be careful in dinit, we gotta figure out somehow to make sure that the swap chain is not being used, is finished, and then we can actually go ahead and deinitialize it. So probably in dinit function we can have to figure out something to make sure that the swap chain is actually finished, and then we could destroy it. But yeah, pretty much. So that's hopefully pretty much it. Now I just need to figure out how I can actually recreate the swap chain. I mean, we already have all sorts of cool stuff. Now I just gotta figure out, like, when the size of the window changes, you have to recreate the swap chain. So let's see how we can do that. Well, I guess we could say c.sdl. Well, hold on, c.sdl. Not sure, maybe window resized. There you go, window event resized. And at that point, maybe we can do simply, let's see. Let's see. Now, if maybe surface, first of all. So do we have a surface currently? If not, well, what we gotta do at that point? Like we don't even have a surface. So if maybe surface, then we can get the surface. Now, if maybe swap chain, then we could basically, or honestly, we don't even need to do this. We can basically just say create swap chain. So maybe swap chain is equal to try swap chain extension, create swap chain, and then here maybe all swap chain, we could just pass in there maybe swap chain. It's kind of weird, but there you go. It's pretty cool. So it just fits it perfectly, I think. Lovely. Create swap chain. Yeah, amazing. So if there is a surface currently, then we basically set maybe swap chain to try swap chain extension, create the swap chain again, but of course reuse that maybe swap chain there, basically. That's pretty cool. Let me tell you that is pretty cool. Now let me make the window resizable and we can find out if that's really good or not. Let's see. Well, where's the window? There you go. Let's add a new flag there. Resizable. And let's figure it out. Let's see. So here's our thing. Now when you actually resize that guy, let me try to clear and then try to resize this. Why I'm not getting anything though? Interesting. Let me try to clear and make sure we're, yeah, API dump, nice. Now let's try it again. Let's clear everything. And we have this window. And yeah, I'm trying to resize, but it doesn't work. I mean, at least it doesn't seem like. Yeah, why? Interesting. Let's see if we're actually getting the event or not. Bro, I need the train to navigate this. Let's see. Where is it? Where is it? Now let me try to say SDL log fmt format as window resized. What? I'm not getting the event. Interesting. What? Okay. Well, hold on. Let me have a look into SDL window resized. Maybe I'm misunderstanding something. Oh, I see. Yeah, I forgot how to. All right, so in fact, you have to say SDL window event. And then afterwards, you have to say event.window.event. Ooh, okay. And then afterwards, you basically switch. Well, you switch on event.window. dot event. Right. And then now if it's SDL window event resized, then we could basically go ahead and do the trick. Now I believe we don't need this. Oh yeah. What? Okay, maybe I don't need this anymore. Then hopefully I could say this. Maybe surface. And there you go. Yeah, I think that's how it should be. Alright, let's try this out. Ooh. Must handle all possibilities. Interesting. Else. Do nothing. Now let's try this out. Okay, zig build run. The moment of truth. And yeah, seems like it's doing the job. Although not sure if it's right. But we gotta figure that out from the validation layer, hopefully. Let's see. So, and yeah, seems all good. But as you can see, we're constantly allocating and freeing every time, which is not great. So, I mean, every time you resize the window, you gotta reallocate, etc. So I think we could optimize this now, hopefully. Let's see. Freeze and allocated and reallocated alloc. Now I wonder what happens if you pass null to free. What happens if you pass null to free? Is it legal or not? Well, I could do a little test. To simply say allocated.free. Yep, it doesn't seem like you can. So I have to guard after that. Okay. So let's see. Now maybe what we could do here. Destroy image views. Now the previous image views, I think we gotta destroy them. Because the previous images are probably at this point out of date or something. Yeah. But the allocations, well, I think we are basically going to make them optional maybe. And then to simply if images, well, I'm gonna call that maybe images and maybe views. Alright, if maybe images, then we could too simply go ahead and free them. Oops. And same thing with views. If self.maybe images, okay. Now same exact thing with views. Views, free views, okay. Nice, free views. Now we could basically make those null, and if that's null, meaning basically kind of like we're We're basically meaning here that we don't own the views and the images anymore. We don't own the array if it's null, too simply. So since I've done this, now I could too simply go ahead here, make sure to put this as maybe views and here maybe images. That's one thing. The other thing is, let's see. So let's figure out what's going on here. Maybe alt swap chain, image count. Now we gotta indeed make sure that the images count matches, otherwise we're gonna have a disaster. So after getting my image counts, now at that point in time, we gotta see if the image counts actually the same with maybe alt swap chain thing. So in fact, let me grab this guy here, from here to after getting the count, which is here. So if maybe alt swap chain, now there is two cases. There is either you do not have an alt swap chain, and at that point you allocate, or you have an alt swap chain but they're not the same size, and then you have to at that point reallocate though. And Travis Tellock, welcome to the live stream. Welcome back. How's the render going? Yeah, I almost finished the render context pretty much. After a while we're gonna actually start the actual pipeline and command buffer, like command buffer, and what else, fences, etc. It's like starting the actual main loop. Until now we're still initializing the application. Like around, how much lines until now? Yeah, until now we got around 597. But as I said before, once we reached a triangle, hopefully it would be much easier to advance, to much better, cooler stuff, basically. But yeah, pretty much. It's going pretty well, honestly, at this point. It's going pretty well. Pretty satisfied with the design decisions I made so far. Pretty satisfied with a lot of beautiful things. So yeah, it's going pretty cool. It's taking a lot of time though. Like a lot of time, but yeah, it's very fun. It's pretty good exercise if you're looking for kind of software engineering problem solving and how to design a project, because there's just a lot of moving parts in Vulkan. So yeah, it's crazy. Especially there's also the fact that you have to load all function pointers yourself instead of just statically linked to a library, and there you go, done. You have to manage everything yourself. Pretty cool. There's even some extensions that would allow you to manage even more crazier stuff. Like, for example, the swap chain is being handled for us. Well, the swap chain images, etc., is being handled for us by the operating system, I believe. But you could indeed like enable a swap chain extension. Actually, it's called maintenance, I believe. Maintenance extension, Vulkan. And that would allow you to actually manage all the swap chain stuff yourself, like manage the images, manage all that crazy stuff. But I'd like to stay away from extensions currently to maintain as much compatibility as possible, hopefully. Especially that my phone only supports Vulkan 1.0. I'm not sure which extensions though it supports. Hold on, let me see. My phone is pretty old and it's still alive, so I mean, if it works, don't touch it. So where is it? Hold on. Which Android it is? Let's see. It's Android version, like API level 27, Android version 8.1. So it's very old. So Vulkan version is 1.0.61. Okay, what else? OpenGL, Vulkan. Okay, Vulkan extensions. There. Oh yeah, maintenance extension is actually available on my phone, so that's nice. So we could indeed try at some point, but for now, I'll just stay away from extensions as much as possible. But that would be interesting to try out later on. Let's see, maintenance. Okay, instance GFW. Okay, there isn't this ARM thing. Where's maintenance extension here? I'm not sure, but anyway, so there is a maintenance extension to allow you to actually handle the swap chain, all the swap chain stuff yourself. But anyway, so for now, let me try to figure out what's going on here. So if in old swap chain, old swap chain, right? A dot, maybe images. Ooh. Well, I'm going to just see. Yeah, okay. So if that's the case, dot len is equal to images count, then at this point we could just reuse the images, reuse the allocations. Else here we gotta actually just allocate. Here we gotta really reallocate, you know, and here we gotta allocate basically. So here we gotta reuse the allocations, the best path, and here reallocate because we don't have the same image count, and here we are gonna allocate because we don't have an old swap chain. So yeah, that's pretty much gonna be it. So let's see. So here I'm allocating views. So in fact, I'm going to basically put those as variables. So var images. Let's see, vk dot c dot vk image. There you go, and equal to in the find. Can I do that? Var image views. All right, let's see. So views, it's also c dot vk image view equal to in the find. In the find is pretty dangerous, but I don't care. Okay, so reuse the allocations. Now here, in this case, we're allocating, as you can see, images equal try allocator.alloc. And then we're basically getting the swap chain images. Well, we're gonna get the swap chain images either way. So yeah, and here error defer allocator.free. Okay, cool. In fact, this guy right here, I should probably, yeah, I should honestly do it here, right? And now I don't need this anymore. And here the views, we gotta allocate here. So error defer, let's go. Views is equal to that guy, images count. Cool. I'm going to put this afterwards, I think. Get swap chain images. Yes. All right, cool. Now that's allocate. Now reallocate, how are we gonna do that? I actually never reallocated in Zig before, so let's find out. Yeah, it's pretty simple. Realloc. Here you give it the old memory, which is to simply yeah, old memory is basically old swap chain, maybe images. Really, yeah, okay. Realloc that. And the new n is to simply the images count. And let's go. That's the first one. Second one is views. Is equal try realloc old swap chain, maybe views. My gosh, do you start a new project every day? Do you have published projects? Def Risco. Yeah, I always try new things. How is it going? Welcome to the live stream. Realloc. Okay. Maybe views, because I'm living on the on the edge, on the bleeding edge. So anyways, maybe views, images count. So there you go. These are getting reallocated. Amazing. Now here we're just gonna reuse the allocations. So images is equal to alt swap chain images, pretty much. Oops. And same thing here. Views is equal to that guy. All right, pretty much. So reuse the allocations. So basically, if we have an alt swap chain and the length matches, then we reuse. Else, if the length doesn't match, we reallocate. If there's no alt swap chain, then we just allocate, pretty much. Yep, makes sense. Error defer. So if an error happens, we freeze all the memory. And yeah, pretty much. Lovely. And that should hopefully work in theory. Here we're getting the swap chain images. Of course, we have to get the images. Then here we're creating image views. All right, cool, amazing. So let's try this out. Zig build run. No field named views in struct. Okay, easy. Maybe views. Oh, what I'm doing here. Oh yeah, gotcha. Maybe views. Oh, in fact, I could just, yeah, makes sense. So let's just go ahead, do this here. Travis Talok, looks like you're calling alt swap chain.dnit and then using alt swap chain later. Is that right? Yep, it's kind of weird, but that's how it works, I guess. So yeah, it's pretty weird because you're just telling that to the Vulkan API that you're going to d'init that swap chain later, so you could basically reuse stuff from that or whatever, basically. So yeah, destroy image view. Here what we gotta do, okay, here we gotta actually loop through. Well, hold on, I need that thing. So, and we just gotta do it here. Views, for views, view, and we destroy the image view, and there you go. And there you go, seems to be working. Now the moment of truth. Oopsies. Segmentation fault. I knew this was coming. All right. So I've done something wrong. Amazing. Don't handle memory like this, kids. Don't do this at home. All right, let's see what I've done wrong. Segmentation default at address 0x7f 7f 6031 4a. Small alloc, small free. Ooh. Yeah, I freed it and then I tried to use it maybe, or something like that. Okay, let's figure out how that's happened. Realloc, maybe images, maybe views. I'm going to try one thing just to test, which is to make sure I'm not double freeing or something or whatever, something like that. So for now, I'm just going to ignore this guy, just to see what's going to happen there. If the problem is there or some other. Yeah, it seems like maybe that's the problem. All right, interesting. Okay. So I guess we have some problem here. So we're checking if maybe views. So, yeah, I think I know what's going on here. I think I know, which is now reuse the allocations. Now, if we find the old swap chain after this whole mess, we gotta make sure to actually set the to null. Like maybe images should be set to null. Basically, we're telling the old swap chain to basically. Oh, by the way, oh my god, I have to actually de-init that guy after this. And in fact, before, after this guy, okay. So I'm going to basically set those to null. So basically telling the swap chain that you don't own those allocations anymore. So don't bother. And yeah, that should hopefully fix it. Cannot assign to constant. Ooh, what? Old swap chain. Oh yeah, makes sense. I guess I have to do it this way. And cannot assign to constant. I guess I should do it like that. What? Okay, I think I probably need to pass it by reference. So maybe old swap chain. Add that guy there. And yeah. Let's see. Those undefined right there, those undefined stuff, is just like a bomb ticking. You know, just here you got a UB. So that's crazy. Oh, anyway. Alt swap chain, maybe images. Okay, let's try to see what's gonna happen here. Yes, does not support field access. So I gotta dereference it. And also same thing with, I guess this guy, maybe this guy, this guy. Yeah, maybe. Let's see. Does not support field access, maybe images. Oh yeah. No field or member function named in. Oh yes. Optional type child cannot cast into optional type child. What? Let's see. Oh, I see. Maybe swap chain. So, interestingly, well, no, it's probably not that way. I need to basically right now. It's like there is a difference between optional offer reference or reference optional. So too simply, let's see. Did you forget to pass by ref at the call site? Yes. Just hold on a second. Maybe swap chain. Try create swap chain. Now basically the deal here is that if maybe swap chain. Oops. If maybe swap chain, then what I gotta do is then I gotta pass it by reference. Okay, else null. I think that's how it should be. Okay, there's a lot of crazy stuff here. Well, old maybe. Cast discards const qualifier. Expected type. That guy found const. Main of swap chain. What? Expected type. Oh, gotta be a reference there. This is going crazy. This is going wild. All right, I guess maybe I figured it out. It was weird, but maybe it's working. But who knows? All right. Okay, so we have some validation problems. Let's find out what are those. And as you can see, we're no longer allocating when we're recreating the swap chain. You said what? Swap chain dot. You're talking about this guy. But no, I had it like that, but it didn't work, I think. Isn't it? Hold on. Let's try it again. Why not? Ooh, what? How? How in the world? Okay, alright, gotcha. Alright, interesting. That was before you changed the capture. Oh, well, makes sense. That was wild. Well, that was wild. But there you go. As you can see right now, we're not reallocating when we're just recreating the swap chain. So that's much nicer. But now we got some validation layers from Vulkan, which I got to figure it out here. So error spec. So called with image extent 865, 478, which is outside the bounds returned by VK physical device surface capabilities. Current extent equal to 846, 457. Ooh, okay. Maximum image extent is that guy. The Vulkan spec states image extent must be between minimum image extent and maximum image extent. So yeah, it's not fine, and it's not enough to actually just use the window extent. So it seems like you have to make sure you're going with current image extent if possible. Okay, let's try to fix that. Okay, interesting. Surface.window.get extent. Interesting. Now the thing is, we gotta basically use surface capability. Seems like that whole if expression should be replaced by just maybe swap chain IDK. Well, you need the address, isn't it? I guess you need the address. But hold on, let me try first of all to fix this one, and then we can get back to that. Well, here, let's actually get the surface capabilities. Why it's not giving me autocomplete? Okay, current extent. Now the problem, as I said, with current extent is that there is a special case there. Current extent, there you go, is the current width and height of the surface, or the special value. Okay, so it could be the special value indicating that the surface size will be determined by the extent of a swap chain targeting the surface. All right, interesting. Okay, so to just easily handle this, I'm just going to say call equal to image extent. Okay, and now here I'm going to try to figure it out. So const image extent, image extent like this, equal to image extent. And let's see, in use block. Okay, now if surface capabilities dot current extent dot width or height or whatever, it doesn't matter, is equal to std dot let's see, dot math dot max int u32. Now if that's the case, then we just gotta break image extent, and we gotta give it the surface dot get extent. Oops, what is it? Dot window. There you go, dot get extent. That's the case. Else, otherwise we're going to break image extent. Let's see. Then otherwise we're just going to use surface capabilities dot current extent. Right. So let's try that out. And I'm recreating the swap chain now. And it seems all good. Not sure if it's perfect, but I don't get any error. Either from Vulkan or... But there's one case though that I still didn't actually handle. Which is when the window becomes 0, 0. I don't think that's possible on Linux. I mean X11. You don't need that image extent label, it can just be an if expression. Ooh. Really? Are you really? Like really? Hold on, let me try that. Like break works with if? You sure? You sure about that? Outside loop, but how do you actually return this guy? How? Remove the break. Are you kidding me? Is that just added to Zig? Oh, well. And curlies and middle semicolon. And curlies. Oh, well, ternary. Okay, gotcha. Well, that makes sense. Ternary operator makes sense. fx true, else false. Yep. Oh, there you go. Looks kind of weird though. But yeah, there you go. Amazing. Amazing. So pretty much we got the swap chain ready. We got it created and recreated. Oh, what is these validation layers for? Let's see. Much better. Okay, so we have another validation problem. Child objects created on the device must have been destroyed prior to destroying the device. Ooh. So image view has not been destroyed. Interesting. VK image view has not been destroyed. Is it just the VK image views? Oh, hold on. Why? Maybe image views, maybe views. Self.maybe views. For views, view, destroy image view. Oh, well. Oh, I think I know what's the problem here. Yeah, I think I know what's the problem here. Yeah. Makes sense. So I gotta always destroy the image views. But I'm only wanting to reuse the allocation. Makes sense. So honestly, maybe instead of doing it this way, what I could maybe do is to have like a Boolean value which indicates if we own the allocations or not. Because I still need the access to those arrays to be able to actually destroy the image views first of all. Makes sense. Well, makes total sense. So I guess is owned are allocations owned. I'm just gonna call it is owned. Okay, and let's see. Or maybe we could call it is retired. Is retired. Okay, cool. Boolean. There you go. Is retired. Now is retired. I think by default it would be false, I guess. Basically. And now if not is retired, so what we could do now is, well, just remove this, guys, and it makes the code much more simpler, I think. Okay, now the only thing here that we gotta have a condition, if not is retired. Oops, not self dot is retired, then do that stuff. Then basically free the views and free the images. If not is retired. Okay. Or we could also call it is recreated. Not really. Just let's go with that. Okay, fine. Here we gotta go with self.views, and we no longer need that maybe thing there. Okay, and then here of course self.views, self.images. If not, self is retired. Cool. Destroy swap chain. We would like to always destroy swap chain, right? Yes. And we would like to always destroy the image views. Okay. Now what we gotta do, we gotta do some changes there. It's gotta be a bit of, well, let's see. If all swap chain, maybe images.len. Well, right now it became images. Okay, .len is equal to images count, then basically say .images .views, and then remove the maybe and remove that guy. I'm not sure what he's called. And maybe images, maybe views. Okay, so instead of doing this, now you simply say all swap chain dot dat dot dereference, and then you say dot is retired is equal to true. And that's much better because you do not have to basically make sure to set both null or both whatever. All right, cool. So you just set one Boolean value, and there you go. Dot dinit else allocate. Okay, cool. Is retired the init. Okay, I think that's maybe it. Oh well, images, not maybe images. Images, views. Images count, PDR. Yeah, I think pretty much that's it, maybe. Lovely. I can't believe it compiled successfully at first try. But let's go. So, alright, now it seems to be great. We're doing everything correctly. But, as I said before, we only need to handle one other edge case, which is on Windows. You can actually resize the window to be 0. I think maybe when it gets minimized though. So or something like that. I don't know, but either way, you gotta actually, you cannot create a swap chain of size 0. So we gotta actually go ahead and make sure we don't do that. Let's see how we're gonna deal with that. Well. Okay, we actually have the current extent in the create swap chain function. So after getting the image extent, we have to make sure it's not 0. So if image extent dot width equals 0, or image extent dot height is equal to 0, then at this point we cannot create a swap chain. We cannot recreate it. Like we just haven't, we at that point we're just going to de-init the swap chain, and yeah. But how? Maybe use std math clamp. Hold on a second, hold on. Swap chain. But we can, so we have to return a swap chain, but we could make that optional basically. Yeah, we could make that optional. Interesting. Because at this point, if that happens, then we cannot really create the swap chain at that point. So pretty much what we're going to do at this point, we're just going to return null. But of course, before returning null, we have to make sure to basically remove the current swap chain. So let's see, old swap chain. So if there is an old swap chain, so if maybe old swap chain. So if there is an old swap chain, then we're basically going to de-init that swap chain. And yeah, pretty much, I think that should probably be it. Yes, and of course we don't set in this case the retard is retard thing. So because we're not recreating another swap chain, we're just creating, we're just not recreating any swap chain. Okay, so that's pretty much it, I believe. So I just gotta make sure I'm doing this right now. Let's see, maybe old swap chain, maybe swap chain, create swap chain, try, amazing. Yeah, I think so. I think we're all good to go. Although one little thing, oh yeah, it's fine, yeah. Maybe surface equal null. Ooh. Well, I'm not checking if there's a swap chain already for whatever reason. But no, I mean, if you don't have a surface, it is impossible to have a swap chain. So yeah, that makes sense. If maybe surface, if maybe swap chain. If there is a surface, if there is a swap chain. Okay, amazing. I think this should work right now perfectly. Although it needs some testing on other platforms like Windows, Mac OS, and of course Android. But I tried as much as possible, to my knowledge, to make this as cross-platform as possible. At least according to my current knowledge. So yeah, pretty much. So yeah, I think mission successful. Mission successful. Yes. But still, of course, you have to, if anyone have Windows or Mac OS or whatever, please try this out. If someone could try to make this work on Android, like to try to build this on Android, I still have no idea how to do that on Zig yet, but we could try it later on. But there you go, pretty much. I'm not sure how much time is left, so let's see. Okay, well, there's around 1 hour left, but I'm not sure. So is there any questions though at this point? Is there any questions? I think The creation and recreation of the swap chain are done. Now, pretty much at this point, we're done with the initialization of the application. Now, what comes next is basically, what happens every frame. Oh, well, no, actually, no. But indeed, we did kind of like the primary initialization, we're done. But later on, like now we just have to create a pipeline, a command buffer, a command pool. But yeah, there is some other stuff left. But generally, most of the stuff that is left is kind of like the framing stuff. Could you try removing that if XPR? Seems like maybe old swap chain, maybe swap chain should work. If XPR, what you talking about? Maybe on swap chain. Which line exactly? Oops, maybe. Which one? Which line you're talking about? $441, I think. You mean 443? Oops, never mind, not 40. You just skipped past it. 443. This guy? What do you mean? Could you try removing that? If XPR, seems like maybe old swap chain maybe should work. Old? No, but I need the handle. Maybe old. I need the handle. Never mind, it was a different one. Yeah, I do remember like we were talking about one of them, but it had an if, that's for sure. Maybe old swap chain. Oh, I guess you're talking about the one in... I guess this one? Yeah, I guess you were talking about this one before. Yeah, I think this one. 589. What was your suggestion? I guess you basically... You said maybe we could just pass in maybe swap chain. No, it needs to be... Optional type child main swap chain cannot cast into optional type child main swap chain. That doesn't seem to work. Is that what you wanted, Travis? Da, 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 da. Okay, my bad. All right. So yeah, there you go. Pretty much. So that's pretty much it for the swap chain stuff. So let's actually, I guess, commit this. How much I wrote today? Okay, let's just go through the changes I've done today in today's stream. There was a lot of changes today. Okay, let's see. So first of all, I included built-in. I added this helper function called map vacay error, which too simply gets a vacay result, and if the result is a success result, we just return, we do nothing, and otherwise we just return switch. We switch on that as a result. But currently I'm not really mapping any results. I may do this off camera. It's just a tedious work of just mapping vacay results into actual Zig results, or we could even generate them through Python or something like that. Other than that, there is I added create device and get device proc ADDR to the dispatch of instance. And other than that, I removed all this craziness right here. I put in another place, and here we added flags. Now if the OS we're compiling to is Mac OS, iOS, tvOS, then we basically include the enumerate portable. Basically any Apple product, we include the create enumerate portability bit KHR because it needs to be there for what is it called, molten vacate to work, I think. And then here I removed this guy and I basically replaced it. Yeah, I used my utility, and now I can cut down this whole condition with just this guy in one line, which is much better. Look at that. And then here we got dot dispatch. So dispatch equal to, okay, so now instead of using that dispatch struct to initialize itself, I'm just using the Vulkan library to do that. So Vulkan library.lloyd dispatch suffix. I also added the suffix, but in this case it's nothing because this is core functions, core dispatch, and not an extension. But you'll see how that would help later on. Instance is the handle, of course, and other than that, we have create surface. I removed that for some reason. Yeah, I added it somewhere else. And then here, as you can see, I added this get device proc ADDR. Well, that's a lot of crazy stuff. And then Lloyd function for the device dispatch stuff. And then basically I removed this stuff and it replaced it with this. Look at that. It really simplifies the code much better. Just using a little utility function that uses zig error handling. So that's very, very nice. And then you have this guy. I just changed what's going on here. I think I probably just added a resizable flag there. Yeah. And other than that, I added the get extend function, which basically gets the size of the Vulkan thing, the Vulkan, like the window. And then additional extension count here. I should probably replace this with an array list because this is kind of clunky and probably not so reliable. It can either easily break down, but this is just kind of like a hacky solution for now. So I don't have to use an array list, but I should probably change this honestly. Yeah, and then what else? I removed this get platform function because I'm not using it anymore. I'm using Zig ABI to check if we are on Android or not. And then here we got Lloyd function. I added that too to the Vulkan library. So basically I just changed this. I removed it from the dispatch struct and I added it to the Vulkan library instead. And it's much nicer in my opinion. And then here there is the surface. Now a surface contains all this stuff right now. Pretty cool stuff. DNet, get presentation support, get capabilities. And also one major change I also did was that I separated the core dispatch, the core functions, from extension functions. So in the future, if we want to have like optional extensions or something like that, we could easily do that. And so our design is much more extensible and you know, separated. But anyway, so here we got a surface extension kind of struct. It's have its own dispatch kind of thing. Then there's a Lloyd function, create surface. Okay, cool. And then okay, deinit. I removed this deinit function for some reason. Oh, that was for the surface. Okay. And then get presentation support. Here we got the adapter. There is a request device function. So basically today we have created the device. And you can notice again that we have some hackery here to see if we are on an Apple product. If we are on an Apple product or an Apple OS, then we basically add the portability enumeration extension name. But again, this is also a little hacky. We should probably use an array list here. And yeah, map vacay error. Yeah. And of course we have loaded the device dispatch, the device functions. We got the device queue, and here of course the device. We created the image view. That's just utility function to create image views. And of course the swap chain extension, which is a device extension. And yeah, pretty much create swap chain. Oh well, create swap chain function. There you go. Much crazier than I thought. But anyway, call swap chain is retard. Okay, deinit. And yeah, surface extension. Now we're just, instead of getting platform and checking if it's Android using SDL, at this point you're just checking if built-in target ABI is Android or not. If it's not Android, then we're immediately creating the surface. So adapter device. So here we're just getting the device, swap chain extension. After that we're loading it from the device, and then maybe swap chain. So of course the first maybe swap chain, deinit, surface, same thing. Well, here maybe surface. Okay, so basically if we have already created the surface, then we create the swap chain at that point immediately. And of course finally, well, not finally, but there you go, SDL window event. We're checking if that event is resized. If that's the case, then we're recreating the swap chain pretty much. And then we have did enter foreground. This is for Android and iOS and phones in general. So when the application enters the foreground, so basically the application is on the user phone, at that point we just create the surface at that point, because that's the only part. Like, we cannot create a surface on Android until we get this event. So there you go. But by the way, this would also work the same in iOS, although iOS doesn't really require that. But this is still fine, in fact, because we're making sure that if there's already a surface, then we don't recreate it, to make sure we don't have a memory leak or something like that. Although we may make like an abstraction later on, I guess. Oh, I see it now. I think you could replace that if XPR with simply maybe swap chain. Ooh, I'll have a look. But let's just finish this up, and app will enter background. Now when the user gets out of the application, he doesn't quit it, but he just goes back to home. You need, at that point in Android at least, the surface is invalid. You shouldn't use it anymore, otherwise anything could happen. And so here I'm making sure to actually destroy the surface, and of course destroying the swap chain. Yeah, but of course destroying the swap chain first, then the surface. And yeah, pretty much. Now, oh, sorry to keep bothering you about it. No, I also love such little improvements, but there you go. Where is it? I think it's right here, I guess. Let's see. Maybe swap chain. That would be great if it works. Yeah, it doesn't. Because I think I tried this, but the thing is, there is a difference between optional pointer and pointer to an optional, basically. So that's why it doesn't work that way. Because I think I tried this before, but yeah. So yeah, that's pretty much it. Right now I think I'm just going to source control, or since we still have a little bit of time left, let's see. Yes, we still have a little bit of time left. I guess I'll address the issue that I talked about, that maybe we'd like to use an array list instead of that hacky method of doing it. So okay, let's figure it out, I guess. Oh, I see. Gotcha. Makes sense. Okay. By the way, is there any questions? Any questions until now? And basically up to the swap chain, you got 600 lines of code. Now, of course, you could make this much, much smaller if you don't care about cross-platform, and if you don't care about you know, like Lloydian function pointers for performance, then you could probably make it much smaller. But with all the improvements that I'm thinking about, there you go. We got it to around 620 lines of code until now. Pretty much. So yeah. But this is one of the things that I was quite scared about. But thankfully, it's always done. And now I'm very satisfied of what we've done so far. And the next stuff, it's not very crazy. It's just pretty normal stuff overall, of course, but anyways. Okay, so let's go and make the array list. Where is the extension stuff? Let's see. Okay, cool. Okay, right here, right around here. So instead of allocating, I'd like to actually make this into an array list. So how to do that? Well, no idea. Let's see, std.array list. Comtime t-type. Comtime t-type. All right, let's see. So that's the T. I guess const extension is equal to that. So init and init capacity, I guess. Okay, here we give it the allocator and here the number, which is essentially extensions count plus additional extension count. But really, it's going to be the exact same thing, I believe. Oh, well. Capacity. Yeah, honestly, I'm not sure how that's going to go. Because you do need the allocation after all. Oh well, I guess for now it's fine anyways. I may actually change this later on, but right now let's just stay here. Let me make sure I'm doing that right. Okay, cool. Now let's just actually commit this guy. Stream 2 commit. There are no staged changes. Oh, hold on. Stream 2 commit. Sync changes. Okay. There you go. And the changes are up. If anyone would like to check the code, see if you can fix something or enhance something or whatever, please feel free to do that. So where is it? ZigVK, I believe. There you go. Alrighty. And yeah, there you go. That's the change. So how much we have done today? Let's see. Okay, 358 additions and 48 deletions. Crazy stuff. All right. There you go, the link. Let's go. And I think that was it. Oh my god. Let's go. Let's go. Is there any questions so far? Have a good one. Goodbye, Travis. Thank you for watching. Since I haven't pushed my... Wish I could see that, since I haven't pushed my engine up, so I can really see how many lines I've done. Oh, yeah. Oh, well. Oh, well, oh, well. Alright. I'm not sure if we could start real quick, try to start presenting images already. So maybe we could get a black screen, a black window, possibly. Depends though, I'm not sure on Linux if that's the case. But I guess maybe we could try that out now. Let's see, I'm not sure. I may be underestimating it though. Well, let's find out, I guess. Let's find out. So we basically need to acquire images from the swap chain every frame, and we need to pretty much present them. But before that, we need to create a fence, so we could wait on that fence. Okay, I guess let's see if we can figure it out real quick. All right, let's see. So where is it? In the swap chain. Okay, well. So here we're handling inputs. This is the input kind of thing. And now here is the render. Maybe we could put this into its own thing, like split this up a bit or something. Anyway, so, and by the way, nada dada, welcome to live stream. Let's go. All right, so let's see. Acquire image. So image index. Well, const image index is equal to try map vk error, and then here we need vk acquire image. I think it's part of the swap chain extension, probably. Yeah, vk acquire next image khr. Oops, there you go. It's right here. It needs a device, a swap chain, timeout, semaphore, fence, and pimage index. But of course, we only have to provide one. I mean, we could provide both, but we only have to provide one. So right now we don't have a semaphore. We don't need it right now because we don't have any rendering going on. But we could basically synchronize the CPU with that operation with the fence. And then of course it gives us the image index pretty much. All right, well, swap chain, timeout. So first of all, before this though, we have to create a fence to use here. Well, how are we gonna deal with that fence? Okay, let's see. I think it's part of the device core functions. So let's actually add that. Create fence, I believe, cd.meta.child c.pfn vk create fence. There you go, equal and defined. Nice. So we got create fence now. Amazing. Now I could use it. And of course we also need the destroy fence. cd.meta.child c.pfn vk destroy fence equal to undefined. Let's go. And oh, off camera I'll probably have a little visit on error defers because I probably missed some. So yeah, destroy fence. But anyway, create fence, destroy fence. All right, so that's what we need now. So I guess I could create its own struct. Const fence is equal to a struct const self. I did indeed want it at some point to just basically not abstract anything and do everything on the main function, but that was like, what? That was kind of like impossible, with the all the moving parts and and all that crazy stuff. So yeah. So we're just going with kind of an OPP-ish kind of thing. But anyways, fn init, just to handle the complexity a bit, to abstract it away. So anyway, init here, error self. Okay, fn dinit, and of course it needs self, and then void. There you go. I should really make some sort of a shortcut to actually generate this guy, like the skeleton of these classes, etc. But anyways, so of course we need the device, or honestly, instead of having an init function, I'm just going to create a factory function on inside of instance. No, the device. Sorry, the device. Yeah. So here, create image view, create fence. Void. Oh, not void. Error or fence. There you go. Great, 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 great. So now let's see how we can do this. So self.dispatch create fence. So what that requires, oh, I don't have self. Okay, what that requires, okay, it requires a device, fence create info, allocation callbacks, and then it gives me the fence. Okay, great. So var handle c.vk fence, pretty much equal undefined. Amazing. And now pretty much what we're going to do is self.handle here, and then here we gotta say std.mem.0 init com time type. Here we gotta say c.vk fence create info, and then finally init. But after that you need the allocation callbacks, and then finally the handle reference. And yeah, and now I'm just going to copy this allocation callbacks here. Alright, and as you've noticed, I'm not trying to hide Vulkan stuff. I'm just working with it. I'm only abstracting, of course, things that needs, you know, initialization, deinitialization, etc., etc. But anyway, so create fence. So there you go. We got these guys in S-type, pnex, and flags. Oh, pretty cool, huh? VK, let's see, flag. Well, fence. Create flag bits. Okay, there's one flag which is create signal bit. All right, cool. Cool. So now here, S-type is, oopsies, S-type is equal to C dot, well, structure type, oops, vk structure type, and then here I'm say fence create info, and then yeah, I think that's it for now. Later on maybe I would need that signal bit flag, possibly, who knows, but we'll see. Other than that, this probably can fail, yeah, so I could just say try map vk error. Amazing. And then finally you return the handle. Well, in fact we return dot handle equal handle, and then of course dot allocation callbacks equal allocation callbacks, and yeah, pretty much. And of course you could store in the device, why not, self. And that's pretty much it. Well, handle, allocation, callbacks, and device. Bruh. There you go. So handle, it would be vk.fence, and then allocation callbacks, which is gonna be c.vk allocation callbacks. Well, of course, it would be yeah, an optional pointer, and then finally a device, which is gonna be a device. And that's pretty much it. Now in the deinit function, we gotta go with device dot dispatch dot destroy fence, and then here you would probably need to give it the device handle, and then you need to give it the actual handle, and then finally allocation callbacks. And hopefully I got it right. And there you go. Now let's create a fence. Of course, this is just a test fence right now. But yeah, const fence is equal to fence dot device dot create fence, allocation callbacks null. And now of course we gotta try that though. And then of course the fur fence dot deinit. I just love the fur in there. The fur. Oh yeah. All right, and that's pretty much it for fence. Let's see if this actually goes well. Expected 4 arguments found 2. Expected 4 arguments found 2. Expected 4 arguments found 2. Oh, I see. So that basically needs to probably go somewhere around here, I guess. Yes. And then, hold on. Expected type that. Oh, I see. Makes sense. So let me actually get this guy. What the? Yeah, I gotcha. That's the create info. So const info is equal to this guy, and there we go. And of course we gotta pass in the address of info. And let's go. Now I think you would be creating the fence, but just to make sure, we gotta go ahead, API dump. There's no validation error, so that's amazing. As you can see, it's creating a fence, and it is indeed successful in that. And then of course afterwards it's destroying the fence. Lovely. So that works. That works. Okay, now that we have a fence, we could go to the next stage. So I think in the swap chain extension, where is it? There you go. Now let's add some more stuff here. c.pfn vk acquire next image khr. Okay, and then that's basically acquire next image cd.meta.child. I may not need though that meta.child anymore. Maybe I've seen that maybe on Zig nowadays it may be possible to actually use an optional function and call it basically, but I don't know. I have to try it later on, and that would really simplify the code, but on the other hand it would not be quite as perfect because you're not encoding in if the pointer is actually can never be null. So yeah, anyways, Now acquire next image, and also we need another thing, which is, but hold on, let me actually see if this gets actually, you know, yep, there you go, it's good to go. The other thing that I'd like to load is pfn vk, let's see, present kchar, q present kchar, there you go, amazing. And yeah, so I'm just going to basically copy this guy, put it here. Instead of that, put this guy here, and here, just going to copy this guy. Oh well, q present. Oh yeah, I heard about this new feature too. It seems like maybe foo.func will work now. Oh, I thought it may be like func. The function itself is optional. Because if you notice, a lot of my code base is littered with this meta.child. And that's because pointer function types in C are all optionals. Because they could all be null. Which is very unfortunate. So yeah. But I haven't explored the feature. So it could be the thing that you've said instead of what I'm thinking. But anyway, so q present. So we got acquire next image and we got q present. What else? I think that's pretty much it. So you just acquire an image and you present it. And oh, there's one other thing, which is, I guess, we'd like to wait for the fence, I guess. So c dot, yeah, I think it's different when dealing with fn pointers. Well, that's unfortunate. vk, hold on, what the? pfn, there you go. vk, wait for fence, for fences. Okay, cool. Right. Now I actually gotta add this to the device. So where's the device? Device equals struct. There you go. Now I basically got to add this here. So they just to simply do this and then copy this over, copy it here, wait for fences, and put it here, and there you go. Now let's make sure it's all being loaded correctly. I should improve error handling. So for example, when a function pointer fails to load, it would actually tells you the function pointer's name instead of just telling you that it failed. But anyways, that's not my priority right now. Okay, so now we could probably start get going with the actual thing. Right now we're going to actually do stuff per frame. Not sure how much time left though. Oh well, I do not have much time left. Hopefully we could pull it off really quickly. Let's see. So the main loop. Okay, so this actually the input loop. Now here the actual rendering happens. So let's see. First of all, we need an image. I think that's gotta be an image index, which is gonna be u32 and defined. Let's go. And now we gotta do let's see, device dot dispatch dot let's see, create image view, create fence. Found it. Can't share link, but if you search for allow method calls syntax and optional pointers in the release notes. Oh yeah, I'll have a look into it later on. I kind of have limited time, so I'm going to try as much as possible to do it real quick. Hopefully we could complete this in this time. All right. Anyway, let's see. Wait, hold on a second. Oh yeah, not device. Let's go with swap chain. Swap chain extension dot dispatch dot acquire next image, get swap chain image. Okay, acquire next image, and here what we need. Oopsies, what the? There you go. So we need the device, the swap chain, the semaphore, the fence. Ooh, well, That's a lot. Device and swap chain. Okay, let's start by that. Device.handle and then swap chain.handle. Well, if there is a swap chain though. So let's see if there is a swap chain in the first place. So if maybe swap chain, then well, basically gotta make sure to do that. And of course, I believe map vk error. Try. Let's go. And of course, swap chain here dot handle. And then I think the timeout, and in my case I don't care about a timeout, so I'm going to go with std.math.maxint. I believe use 64 in this case, and that's for the timeout. And basically there's no timeout. And what else? There is the semaphore, null, fence, and then a number. Yes. So the semaphore is null, and the fence is, well, our own fence. So fence.handle, comma, and then finally it would give us the next image index, basically. And of course this should be here, because if, well, you do not have a swap chain, there is no rendering to be done. Pretty cool, huh? So, okay, let's go. Now let's see if this actually works in the first place though. Alright, seems to be going greatly. Yes. There you go. Acquire next image, vk not ready. Vk not ready. Yeah, gotcha, makes sense. So, and of course at the end of the day, we gotta say fence, well, in fact device.wait, well, dispatch.wait for fences. Oh well, what this actually gives us. Wait for fences. So you give it the device u32. Oh, that's the count of how much fence. And then bool32. Yeah, I do remember, but this is irrelevant for one fence. And then a u64. I think that's a timeout. Okay, so let's try that out. Okay, cool. Here I think the device handle. And then afterwards the fence, right? The fence. So fence.handle. And then let's see. By the way, can it error? I do think it can error. So, yep. At this point, I just have to assume it errors. And then just check if it doesn't. That would be much nicer. Okay, so other than that, what else? There is a boolean and then u64. So boolean, I'm gonna go with whatever, I don't care. So c.vk, I guess false, anyway. And then the timeout, which is gonna be basically the same thing as this guy, meaning that there is no timeouts. And that's pretty much it. Now it should acquire next image and then just wait for fence. Let's see what's gonna happen at this point. Expected 5 arguments, found 4. Ooh. Oh well, why? So here we got device u32. What is that u32? Interesting. Let me have a look real quick into the documentation. Vacate wait for fences. Oh yeah, my bad, I remembered. So one fence, basically how much fences you have. And in fact, it should be an address of. It's gotta be an array though, too simply. And there you go. But it's saying vacate not ready. Of course, so as you can see, good morning Fly Moon, welcome to the live stream. Destroys image view. So here we're acquiring image, vacate success, it's waiting for that guy. Okay, nice. Well. Now let's actually, I probably need 2 fences though. which is interesting. Wait for fences. Okay, so before waiting for fences, oh, I do need a semaphore, right? My bad. Well, I don't think I'm going to actually be able to do it in this time. Yeah, pretty much, yeah. I don't think. You know, Ziglang, what do you think about it? Ziglang is, in my opinion, it's the best language for such low-level stuff. Low-level stuff. And inherently in safe stuff. Graphics programming by heart isn't safe, so there you go. Right, so, well, at least in my opinion, so yeah. All right, and of course there is Rust, but not in this field. Rust is very painful for this, like for in safe code and for very low level code. So yeah, but basically low level and safe code, Rust is very painful. So Zig really fills that place. So it's basically a replacement for C, while you could say that Rust is a replacement for C++ in some sense. So yeah, pretty much. So yeah, VK acquire next image. Okay, VK present, all right. Try map VK error. Okay, now swap chain extension dot dispatch dot instead of acquire queue present, and what queue present needs. Oops. It needs a queue and present info. Great. So I already have the queue inside of the device. Of course, maybe the handle. No, yeah, it's just the queue. And then finally the info. Okay. So cd.mem.0 init comp time. Well, c.vk present info khr, and then here the init. Okay, cool. In fact, I cannot really do it like this. It's gotta be an info like that. Alrighty, const info is equal to this guy, and then present info khr. Let's go. We just really need a new LSP, and Zig would be my far favorite. Okay. But it's understandable that, you know, everything is still not mature enough. So I cannot complain. VK structure type. But pretty much you can enjoy programming with Zig. Rust, well, depends on the project. If it's a project like this one, you got a long ride, bro. You got a long ride. Type, okay. Let's see. Type what? Oh yeah, the present info. Rust is also good, don't get me wrong, it's also good, but not for this kind of projects that I'm doing right now, or that I'm doing currently. So yeah, wait semaphore count. Wait semaphore count. Alright, so we do need the semaphore, I guess, isn't it? Yes, we do need the semaphore. Oh my god. Yeah, we're not gonna make it. Yeah, we're not gonna make it. Pretty much. Swap chain count. Image indices. Yes, we do need a semaphore. Pretty much. So I gotta basically stop all what I'm doing here and try to create a semaphore first. Oh my god, let's go. Let's try to do it real quick. Well, create fence. There you go. Boop. Then VK create. Instead of fence, we're gonna go with semaphore. VK destroy semaphore. Create fence, destroy semaphore, and there you go. Now I'm just going to create it real quick. Go to const struct fence. Well, const fence equal. There you go. So it's gonna be similar to this guy. pretty much semaphore, and then c.vacate semaphore, allocation callbacks, device, there you go, destroy semaphore, self-device handle, self-handle, allocation callbacks, pretty much. And of course we do need that create function at this point, I guess. Yes, where is create fence? There you go, something similar to this guy, real quick. Right, semaphore, create semaphore, and then vacate fence, semaphore create info, there you go. And then here, of course, this should also change to semaphore. Hopefully I got that right. And then create semaphore. It's basically just changing the name, really, nothing fancy there. And yeah, pretty much. Oh, that's a lot of stuff to change there. Oh yeah, well, that's it. Now let's try to create a semaphore there. Okay, where we're creating that, guy. So const semaphore try device dot create semaphore. Let's go null and k the first semaphore dot dinit. And yeah, I did forget about some things about that I should actually do, but anyways, so semaphore dinit, nice. Let's see if that actually works. Hold on. Yep, the semaphore I think is getting created. Amazing. Now we could basically use it. So S type, and then we need the wait semaphore count. Oopsies. There you go, is equal to 1, and then dot p wait semaphores is equal to address of semaphore dot handle though, and then dot swap chain count swap chain count is equal to 1, and then p swap chains is equal to, well, swap chain address dot handle, of course, and then swap chain count, I already done that. P image indices is equal to address of image index, and then p results would be null, I believe, so I don't need to specify that. And yeah, pretty much that's it, I think. And info, I think that's it, maybe. But also, of course, I need to add the semaphore here. And hopefully that's it. Let's see. Come on. And yeah, I think I've done it at a time, but there is something wrong. Everything is blocked. Okay. Oh, cool. Alright, so that's it. For now, we gotta continue tomorrow, inshallah, and see you later. Goodbye, everyone. Thank you for watching, and thank you for tuning in.